In the meanwhile, the participants are asked to post their queries, whichever you have it, during all the sessions in the chat box, and the team will take care of asking the questions to the delegates and clarifying your doubts. So you are asked to post your questions in the chat box during the session. In addition to that, you have been asked to download Python software. You can also do it in Google Colab, and that will be the third session. Practical session will be handled for machine learning algorithm using Python. Now I request Ms. C. Nitya to introduce our keynote speaker, Dr. P. Ganesh Kumar.
Dr. P. Ganesh Kumar, sir, has received his PhD degree from Anna University in the year of 2013 and postdoctorate from School of Computer Science and Engineering from Gyeongbong Pok National University, South Korea. He is working as assistant professor in the Department of CSE in Anna University, Coimbatore. He is specialized in information technology. He is an expert in the area of data mining and soft computing. He has published around 42 articles in reputed journals and published papers in 62 conferences. Now I request Dr. P. Ganesh Kumar sir to take over the session. Thank you.
So, thank you, ma'am. At the outset, I would like to thank my respected and beloved supervisor, Dr. D. Devaraj sir, for always giving me this kind of opportunity to revise myself every time when I slow down in my progress. So still he is my like a teacher, and he is always monitoring my progress and all. Whenever I am slowing down, he is asking me to do such kind of seminars. So first of all, a great and very good thanks to you, sir. So this presentation, I was asked to deliver a talk on microarray data analysis using machine learning algorithms. Let me share my screen first. Is my screen visible? And is my voice audible?
Yes, sir. Yes, sir.
Yeah, yes. So the topic given to me is microarray data analysis using machine learning algorithms. As I was informed, I have to introduce a little bit about the machine learning ideas, fundamentals of machine learning ideas, followed by different kinds of machine learning algorithms that are widely used for any kind of data analysis, especially microarray data analysis. Then with two different kind of algorithms. One is for selection, another one is for classification. With a simple case study for diabetes microarray data set, I will conclude the session with the MATLAB code development. So to understand the fundamentals of machine learning, you should know the difference between the human and a machine. So to understand a human, I will take a baby, and to understand a machine, I will take a computer. Suppose if a person is asking a question like, who is your father? So what is the difference between human and the machine in terms of intelligence? So in terms of intelligence, when you talk about human, since the human here representing a baby form, he can able to recognize his father. Maybe in a group of people, the child can easily recognize his father, but can't answer. Being the baby form, he can't able to open the mouth. But when the same question is asked to a computer, that computer is a machine, but so he can't recognize and can't answer. So what is the difference between these two picture as the scenario is telling? So one can easily recognize and another can not recognize. That's what the answer that we can have to take. How one can recognize, how one cannot recognize. So that's the thing we need to think about. So when you take about the human learning, how the human learning is happened, because in baby form recognition is there over the period of time, learning has been happened, and the learning can be converted into a kind of a knowledge, and that knowledge will be converted into a form of experience like that. So and the human can able to solve any kind of problems in a well clear manner. So starting from the baby form to more adult form and more old form. So there are many things are available. Many things are available around the human to teach the any problem. To teach any problem, at least he has to gain experience and like that, like that. So human learning is not in a single period. So it has been happened throughout the walk of life, throughout the walk of life. So that thing you should remember. So human learning is not a one-step process, or it's not a one period process. It is happened all along. So what is responsible for this kind of learning behavior is the wonderful structure human brain is responsible for the learning behavior. And who is the responsible for making that human to learn? So in every stage some people are available: parents, teachers, friends, society, spouse, children, colleagues. So these are put together, so converted into a form of an experienced person. That's what we are calling in the machine learning terminology as an expert system. Expert system. So he's an expert, experienced person. He knows many things because he has crossed many challenges, issues, and many problems. So he can easily solve any kind of problem, whatever may be the situation. He can easily tackle the situation. Of course, he had a lot of patience in solving the problem. So all these happened by learning, and there are persons involved to make the human being to learn. And the structure available in the human is a brain, which is more helpful to make one to understand the idea. Likewise, when you take the machine learning, I have given the pictures right from the primitive form to the very smart form. Primitive form of machine, that is first generation computers, to the latest generation smart device gadgets. So in all the cases, what is written is some kind, what is required to understand a particular problem and can able to solve the problem is you need to write some programs. That is that some kind of code has to be available in that machine. Then that code will be able to do these kind of tasks. So that is called algorithm. That is called algorithm. That is, what is that? So whenever you find a problem context, from that problem context, you need to generate, or you need to collect as much as data possible using the data, and based on the characteristics of the data, because these devices are going to accept our data only. You are going to give your input. The inputs are nothing but data, right? So that based on the data that is given, either you can give the input, or the machine can automatically senses the input, and according to the sensed input, or according to the feeded input, it has to respond. That's what the output we are expecting. So whenever something is told, the machine has to respond. So if for which we need the you expect the machine to learn something. If that machine learns something, then only it reproduce the thing what we are expecting from the machine. So for which what you need is, you need to create a machine, or you need to inculcate the machine according to the way in which you are expecting to solve a certain things, or to represent certain things, or to respond to certain things. So for that, whatever may be the problem you are expecting the machine to solve, from that problem you need to take the input, that is means the data, and based on the data characteristic, you need to devise an algorithm. That algorithm can be converted into a form of program, and then that program has been embedded into a machine. Now you can say that the machine is an autonomous system, and can work individually without the intervention of human being for any kind of problems. Of course, human intervention is there, but reasonably we can avoid that human intervention when it is deployed for a automated process. That's the thing we need to take it from this slide. So what is the difference between the traditional programming and machine learning programming? You see, when you do a program, say for example any sorting algorithm, when you do a program, so what you need to do is you need to give an input here. So input may be, say for example, here if it is a searching algorithm, input may be some numbers, like 5, 10, like that. Some number will be given. So what is asked is we need to want to sort the number in ascending order. So what number comes first? 2 comes first, 5 comes next, 10 comes first. So based on the order of the data, you have to write the program using some data structures or whatever it may be. And then that input along with the program has been fed into the computer. So the computer will work according to the instruction written in the program, and it will produce the output. That is what the traditional program that we are doing for any kind of generic problems. But when you want to make a machine to solve or to give solution to any real world problem, again what you need to do is, so the real world, from the real world problem context, you need to take the data. As I mentioned in the previous slide, you need to take the data. So the data is divided into set of inputs and a output, set of input and a output. So you need to give the set of inputs and you need to give the output. So what you are expecting the machine to do is, you have to write here also program is there. I can give program, I can give some kind of instruction here, the instruction, maybe you treat them as some kind of action that machine has to do with respect to input and output. So what is that instruction that machine has to do is, the machine has to study the relationship between the input and output. So if this is the kind of input pattern, then it might be the output. If that might be the kind of input pattern, then this kind of may be the output. Likewise, you need to instruct the computer. This instruction, this set of instruction has been fed into computer via some kind of programming languages like R, Python, MATLAB, whatever it may be, or some higher end programming languages. You need to tell the computer. So once the thing is informed to the computer, the computer will give out some kind of idea, some kind of programs or some kind of concepts which can be embedded into a hardware, and that hardware can be used as a autonomous system. So that's what the idea here. So the main difference between the traditional programming and machine learning programming is their input along with the set of instruction to produce output from the input has been derived. Whereas here, data in the form of input and output is given, and you are making the machine to understand the relationship between the input and output, and you are expecting a kind of instruction. That instruction may be deployed into a machine so that the machine can work as a individual system. That's what the scenario is here in this slide. So how to develop this machine learning model? So you can any machine learning model can be developed via two stages. One is a training stage, another one is testing stage based on the input data given. So during the training stage, the input data has been accepted, and their relations among themselves and the among the between the input and output has been studied. While course of this training time, what is the thing happened is, whatever may be the model that you have chosen for to give output, that model parameters as well as the model structure has to be adjusted according to the mapping, according to the principles of relationship between the input and output. So based on the mapping, you need to adjust the parameter and the structure. After the training stage is over, that is after you reached a suitable response during the training as well as the validation part, so you came to the testing part. So the testing part, you need to give the same kind of data, but that is not used in the training period. And what you need to expect from the model is whether that model that is trained has been well enough to understand the unknown data pattern and produce the results. And based on the results produced, we need to assess the performance of the model, whether it is correct or not, or how much it is correct, or how much it is accurate. So those things have been developed. So this is the generic diagram that discusses about how we have machine learning model has been developed. There are many forms of machine learning. You may have supervised learning, you may have semi-supervised, unsupervised. So of course, in all the situations, what is there is kind of data is there. For example, let me take the first picture. Please, I ask you to recall to the first picture. What is the first picture? This human learning. See, imagine a person in this stage, maybe, yes, in this stage. Imagine a person in this stage. Maybe he is the one who is entering into college. So what kind of knowledge you want to feed the student is machine learning subject. So if I want to teach the adult candidate who is going to college the subject machine learning, so what I need to do is I need to have the syllabus of the subject. I need to have the study material. So based on the syllabus as well as the study material, I need to give the required notes or required present materials or required resources, and then I ask the students to go through it, and based on the way in which I taught the student will according to the subject, he will adjust himself to the subject. So if it is a theory subject, he will have the mindset to go through the theory subject according to the nature. If it is a mathematics subject, he has to pay extra concentration so that he has to write and all. He have to keep. So that what I trying to convey is based on the nature of the subject, human learning can take place according to the subject. If it is very easy subject, not much more time is required. If it is a lesser concentrated subject, that is not mm, that is not possible for that. Yes, may I turn on my video? Yes. So this what the idea is about different forms of machine learning. So based on the data, there are many forms of learning. So if your data contains both input and output, if your data contains both input and output, definitely it is a supervised learning. Of course, yeah, semi-supervised learning also come into picture. But you need to look into the output. If the output is only classification label, it may be in the form of discrete data like first two three or distinction like that, some label class label is there, then it is classification. In case if that output is like 1.2 3.5 like floating point numbers, then definitely you need to carry out a prediction task or regression task. So that's the idea. So if your training data consists not training data in general, if your data consists of input and output, and if you look into the data type of the output, if the output data type is discrete, then you need to conduct only classification task. If the output type is something like floating point value or real value, then you need to go for prediction or regression task. So what about semi-supervised? Semi-supervised learning also, here also you have a data, and the data should have the input and output. But here the few fields are partial. Few fields are partial, and we have only few desired input and outputs, not all possible outcomes. Where we can find such kind of data sets? So we can find such kind of data when you are going to fill up a questionnaire, or when you are going to fill up an application, or when you are going to give your data through any online media or portal or web portal. So there are certain fields that are treated as mandatory, there are certain fields that are treated as optional. So many of the persons omit the optional values and they fill only mandatory. But some persons fill the mandatory data also. So in that case, if you are collecting the data from 100%, maybe or 60% may fill only the mandatory fields. Maybe 40% can take some time to fill all the fields. If you collect all the 100% data, you can find that there are certain inputs that is not available. So there are, of course, any other treatments are also possible to look into the problem as a missing value. But in certain situations, you can take the data as such. So this is the case in which you can use semi-supervised learning. And let me come to the third kind of learning, unsupervised learning. See, supervised learning, you treat the subject as a theoretical subject. Unsupervised learning, semi-supervised learning, you can take the subject as something like a generic subject, which contains a combination of both theory and practical points. But when you come to the unsupervised, it has only input, like a mathematical subject, there's only input. No output is there. So you need to put a lot of effort compared with that supervised learning. You need to put a lot of effort. The algorithms is also seem to be very complex in nature in order to understand the process. That algorithm will, what it does is that algorithm definitely will study the relationship among the input data. So between within the input data, the relationship have been studied. And based on the relationship studied, the algorithm will process the data and it will produce some kind of groups or some kind of clusters. So based on that, then you will proceed to next level, or you can identify the kind of relationship between the input and that particular cluster. So that is what unsupervised learning is about. Then come to reinforcement learning. Here in this case, the data is available in the form of state and action. So this is very particularly useful for online gaming. So there are online gaming or any robotic actions that are required to respond to the action given by the outsiders. So those kind of things you need go for reinforcement learning. Then these are all the learning. One may wonder about what is deep learning. So again, this is the based on the nature of the data. The data is highly non-linear, complex, unstructured, huge in numbers. and one cannot process process it in one go, and you need in-depth analysis of the data. So that's the word, in-depth analysis. So that is each and every layer has to process different forms of the data. At that particular juncture, you go for a different form of learning, just beyond the limit of machine learning, that is deep learning. So this is what the major. So what is learning here? You want to make the machine learn about the problem. So problem in the sense data. So data characteristics, based on the data characteristic, learning differs. So always you have to look for the data when you are going to develop any machine learning algorithms. So the data contains what? If it has input or if it has output. If it contains output, that output is a discrete, like that. So you need to study, you need to do all these kind of stuff before getting into choosing a particular machine learning algorithms. So that's what I want to conclude, the foundations of machine learning algorithms. There are many, you can find lot of algorithms, whatever the algorithm that are interested to make a machine to learn about environment. All those such algorithms are treated as a machine learning algorithm. So when you go for the probability and the statistical based algorithms, you can find linear regression, logistic regression, decision tree, random forest, support vector machine, KNN, K nearest neighbor, naive base, K means. So these are all maybe you may treat that under a particular category of probability and statistics. There are another kind of algorithms which is soft in nature, I guess again to hard computing nature, hard computing techniques that mimics the human behavior in one way or another form. That is neural network, fuzzy logic, evolution algorithm. So this is the most widely used machine learning algorithms for any kind of data analysis. Particularly, you can use these kind of algorithms for microarray data analysis. So let me touch upon each and every machine learning algorithms a little bit. Then I move to the case study. So coming to linear regression, so it is very simpler. It always follows the form of it always try to follow the form of an equation of the form y equal to mx plus c, mx plus b. But what is that does here? Y is treated as the response and x is treated as the input. So that is independent variable. So when you are going to have the x, so why you need to produce. So in that case, you need to find m and b. If you find m and b, that is, if you want to make a relationship between y and x, you need to find the slope m as well as the intercept b. So there are, of course, equations are available in order to find the slope as well as the intercept. So what you need to do is you need to calculate these two things based on the set of x values and the corresponding y values. And then you will have to do a scatter plot from the line of best fit. You need to do or you need to understand how does the line fit the cluster of points. So based on that, you need to classify or you need to predict the future cases. So that's what the linear regression model is all about. So let me have a simple example. You have two variables. One is high school GPA, grade point average of students, and the another column is university grade point average of the students. So what you need to do is from the high school GPA of the student, whether it is possible to predict his or her university GPA or not. So that is the problem here. See, for which you need to calculate summation of x as per the formula in order to find the slope, in order to find the intercept. So you need to find m and b first. So for which you need to find the summation x, summation y, summation xy, summation x square, summation y square. After substituting all this value, you have got m value as well as the b value. Now the equation y equal to mx plus b is converted into the form which is suitable numerical value. Y equal to 1.0775x minus 0.18. That means whenever some x value is given, that x value should be multiplied by 1.007 and it should be subtracted with 0.18 values. That's what this says that. So you do to draw a line. This says that the line starts out at 1.0 and then it decreases by 0.8% of x, 0.18% of x. So that is the idea. And you need to draw a line. Let me say this once again when we, after this correlation. So correlation coefficient also has a similar idea. So it is also used to find a least square line, and it needs to test whether that model is good enough. In general, you want to measure the strength between the two variables, how far the two variables are correlated, whether it is positively correlated or negatively correlated, or at least there is no correlation between the two variables. In order to find that value, you need to calculate the R value. So that is the idea of the correlation coefficient. So you need to calculate the two things, correlation as well as regression. You need to find the difference. So in general, if you look at the correlation, you need to have the scatter plot alone, and this is to say when you are taking two variable x and y, this is to say how the much quantity or how these two variables are related, how much quantity or how much degree these two variables are related. So that's the thing here. And otherwise you may say that it is a kind of statistical measure that that is used to define a kind of relationship or association between two variables. But when you take the case of regression, here you need to fit the variables in a line, and you need to identify whether this y from this set of y we can make a set of predictors. From the set of predictors x, whether we can able to predict the key response y or not. So it tries to fit the variable, whereas the correlation try to quantify the degree to which. So whenever you need to do these two things, there is a little distinction between two things, and you need to clearly understand this idea, correlation as well as regression. Next, logistic regression. So logistic regression is otherwise called by the name generalized linear model. It is of the form that is g of e of y equal to alpha plus beta x1 plus gamma y1. So what is it is? It is like a linear regression model, but that variable, if it is said to be non-linear, that is, it has a number that is the variable as categorical in nature. And if the task is classification, then what is needed? We need not go for linear regression, then logistic regression is the one. So in order to apply this logistic regression, what you need is you need to have some kind of outcome that is of binary, that is 0 and 1, or categorical in nature, and you need to fit the value. So how this logistic regression is find out? You need you have a brief derivation for that, but I do not want to touch upon that. But finally, what you need to get is a log of p by 1 by p, that is equal to beta plus beta of age. So what is this age here is? So in order to predict a variable age, that is the variable for a particular case. So the predictor variable should be there, and that based on the predictor variable, you need to find out the possible t for the particular case. So this is what these logistic regression. This can be understood when I give a demo for that. Next, what is the support vector machine? This is also again based on the statistical learning theory. Here you need to always have a distinction, clear distinction between linear separable data as well as non-linear separable data. When it is linear separable data, the formation of hyperplane with respect to discrimination between one category to another category is very easier. That margin is very easier. But when it is non-linear separable data, then it is a little bit trickier, and you need to find a suitable kernel in order to learn the environment. So the main equation that is used for this separating the hyperplane is this one. Again, the equation seems looks like y equal to mx plus c form. This m is known as weights, set of weights. Here there are two kinds of hyperplanes. One is for positive samples, another one is for negative samples. If you look at it, you can find that idea. So one side there are one set of vectors, and another side another between in both sides of the margin that belongs to one category, and this belongs to another category. When you want to discriminate one category to another category, you need to identify suitable vectors so that the margin is clearly defined. In order to find the suitable margin, this SVM supports a particular optimization algorithm, that is a constraint quadratic optimization algorithm, for which you need to form an equation that is of the form minimize subject to that yi wtxi plus b. So that is the idea. So this hyperplane is adjusted in many of the sites, and ultimately your objective is to occupy or as much as variable possible based on the support vectors. So that's the idea. I will say in the demo what's how it is implemented. Naive Bayes is based on Bayes theorem. You know well about the Bayes theorem. That is the probability of A given B. That is based on this one. So you need to find out the unknown variable based on the given variable. you need to apply this kind of idea in order to understand the posterior probability. That is, the posterior probability is equivalent to how these can be calculated. That is the likelihood and product with the product of proposition prior probability with the ratio of evidence prior probability. That is the idea here, Naive-Bayes theorem. How this Naive-Bayes classification is carried out with respect to C, probability of C, that is the probability that a particular class label belongs to a set of variable xi to xn, that can be calculated. Probability the set of variable belongs to a particular class, probability of the class variable, then the probability of the set of variables. So that's the scenario that you need to calculate for every class variable. Then the followed by for every class variable, then which with respect to the final case, you may end up with a classification label for each category, and which will be very useful for identification of the particular category. So that is by means of the conditional probability of an event with respect to a particular feature vector xn to xn, we can find whether that feature vector belongs to a particular class label or not. So that is easily possible, and this is based on the probability theory. This is another machine learning algorithm, decision tree. With the help of decision tree, you can always end up with a class label. So how that class label can be created is, you need to create a tree. See, this is the kind of data given. Say for example, in a table you can find a data which has age, income, student, credit rating, vice computer nerd. So the last column is the one that is treated as the output column. So the output column contains two category values, yes or no, yes and no, that is. So with respect to this data, you need to draw a tree. That tree will give you a particular idea to reach the class label, whether he yes or no, whether he can buy a computer or not. That is yes or no type. So for which, if you want to draw a tree, the tree should contains a root node, which is to be identified. In order to identify a root node for the decision tree, there are many algorithms available. One popular algorithm is ID3, C4.5, CART, KITE, and MAS. These are the algorithms available in order to identify. See, you are provided this data. This data has to be converted into this tree form. So for in order to convert the data into tree form, you need to identify among. See, these are the input variable. These are the input variable, and you need to know which input variable has to sit as a root node. So once you identify the root node, which is another maybe first left child, and what is the another next right child. So like that the thing goes. Like that the thing goes. So that is the idea here. That is the idea here. Age. So for which if you can use any one of the algorithms, the ID3, C4.5, CART. So when is ID3 can be used, or what is the formula? So for each case, information gain, you have the formulas for calculating the entire variable, entire data, as well as for info of age. Then based on that, you can calculate the gain of each variable. So this is one idea that is followed in ID3. Another one is gain ratio, that is followed in C4.5 algorithm. Here you have to follow that is next version of ID3, or you may say that successor of ID3. Here you have applied a formula with respect to split info. Here the data set is divided into two things. One is for a particular class and the set of data belonging to that class. So that can be identified, and you can find the gain ratio. So based on the value of the gain ratio, again you need to choose the variable which is having highest value and which is having lowest value. That variable can be treated as. And another one is Gini index. Gini index, that is used in CART. So these are the three ideas. So what are the three ideas is, let me say in a brief manner. So these three ideas are used to choose a particular variable to be available as a root variable, and followed by another parent variable until it goes to leaf. So what is the another algorithm is random forest. This random forest is a collection of decision trees. So in the decision tree model, you have drawn only one tree. From that tree, you will be finding out the output. But in random forest, what is there is you need to collect all the you need to draw as much as decision tree possible. From each decision tree, you may use a particular output, and that output will be taken from that using a weighted method, or you may use the idea of bagging to get more accurate as well as a good number of prediction. So that is the random forest. So from here subset of tree with respect to all data, you need to choose one particular tree which best represent the data, or with the help of the bagging model, you need to find out the final output. So the same thing, random forest idea. So here there in only one tree, here n number of trees are drawn, And based on that, you need to choose a particular tree or weighted or a bagging method you need to choose. So what is the nearest neighbor classification algorithm is, here you will be provided this again the same data pattern will be given. Here you need to after projection of the data into the graphical form, you need to calculate the Euclidean distance between the variable. The one which is having closer distance is about to form a particular group. So then with the other one which is that will be treated as another category. So that is the idea here. Here you need to find you need to say in period the value of k. So how much nearest neighbor you can consider while you are considering the case. So based on that, you need to do the classification. So let me briefly introduce the idea of the basic algorithms of a few machine learning algorithms. So all those algorithms can be used for that any data kind of any analysis, especially for micro data analysis. So this is one algorithm that I am going to discuss in detail. That is artificial neural network. See, this artificial neural network can be treated as a distributed parallel processing system, and each unit is treated as a processor which will be processing the data via two forms. One is summation, another one is activation. How it is possible is, in order to understand the principle, you need to understand the biological neuron. So whenever information is, whenever what is the information for a human being in a human brain? The information received by all the sense organs. So all the sense organs information has been taken up as a electrochemical activity or electrochemical signal and fed into the soma. That is the core part of the neuron. Via dendrites, it will move up to the axon and it will store the soma. But the soma has a definite capacity. It will not accept all the information as such. At one particular point of time, it will start ejected information. So that is the information is passing across the neurons. While passing across the neurons, the trivial information or the key information is stored in the synaptic gaps. So the same principle is mimicked in the artificial version, where the soma is asked to do two kind of activity. One is summation activity, another one is threshold activity. Other things are common with respect to that. So if you look at the mathematical model, you have a set of input vector. That input vector is multiplied with the corresponding weight vector. You need to do a weighted sum and you need to apply activation function over it. So once you apply activation function over it, that is you need to apply the you need to find the corresponding output. So this is the mathematical model of the AN. So what do you need to calculate is, you need to always calculate the net input as well as the output. So that's the two things you need to calculate. So if you look at the very complex model, that is backpropagation model, you need a set of input nodes. The input node value is being passed to more than one layer, or at least a single hidden layer it passes to in order to produce the output y. So you have a set of x1, xi, xn, which is treated as a set of inputs, and you have the corresponding outputs y1, yk, ym. So for which you need the you have the target. So you need to compare the target value with respect to the, if there is a difference, then that is treated as a error, and that error is fed back in order to adjust the value of weights. So originally, when you submit the input value x1 and xi and xn, what you need to do is you need to randomly initialize the weight values. Here the weight values are set of v's between x and z, set of w between z and y1. Based on that, you need to randomly initialize the weight value, and you based on that random initial value, you need to calculate the y values, set of y values, and that set of y values will be compared with the targets. Definitely at the one go you have an error. So based on that error, you need to find out the delta weight value. Based on the delta weight value, that is change in weight value, you need to change the weight between these two layers. So this process is going both forward and backward. In the forward, the signals are given. In the backward, errors are given back. So in order to give an exact match, or in order to make the y very close or near to the targets. So this is a goal. So this is algorithm can be understood in three phases: feed forward phase, backpropagation error, weight and bias size. So in feed forward phase, in the two stages, hidden unit stage and the output unit stage, you need to calculate the net input and output. And when the backpropagation time, you need to calculate the error. That is nothing but the difference between, see, if you look at it, difference between the output and the yi over which an activation function is applied. Yeah, and then you calculate the delta weight value, and the delta weight value is used for calculation of the error. And based on the calculation, you need to calculate the weights and bias. So that is the idea. Third phase is the weight and bias updation. Right. So now come to the case study. That is, so these are the major main algorithms. Microarray. technology or microarray and its importance. So when you look at the microarray data, it's a cancer treatment strategy. Mainly, they have invented this idea. The cancer affected portion of the human being has been fed into some scanner like form, where that portion has been generated as an image. From that image, you have the scanning, you have the image analysis. From that, the intensity level of the image which has been exposed to the certain kind of chemical process or a bio process, and that data is being converted into a raw form in the form of a matrix. So where the row corresponds to gene and the column corresponds to samples. So if you look at the data, the samples are nothing but corresponding to pertaining to each and every person, but the gene is enormous in number, enormous in number. So that is the major challenge given by the data. You have dimensionality issue, scarcity issue, disparity issue, and these three challenges can be tackled easily via the selection of suitable machine learning algorithms. Here I am going to discuss about two challenges. One is the dimensionality issue, another one is the classification. This final classification. For dimensionality issue, you can find a lot of cancer related data as well as diabetes data, rheumatoid arthritis data, and you may find the corresponding class labels for each and every data, total number of samples, and the available number of input variables. So this is the slide which is showing the maximum possible data. Of course, still more number of data are available. This is the data that I have used for my experiments. So this one particular data, that is diabetes data. If you look at the data, there are 34 samples, 17% belonging to diabetes mellitus and 17% belonging to normal glucose level. And how many input variables are there is there are about 22,000 variables are there. So that is the thing you need to study before getting into the data. So how the data will be looking like is, this is input variable name, that is gene ID. If you look at it, this is a gene ID. How many number of genes like this you have? 22,000 genes you have. How many number of samples you have? You have only 34 samples. 34 samples. So when you want to develop a machine learning model, so what you need to do is, from the data or according to the characteristics of the data, you have to choose a particular learning algorithm. So here you find what is that? You find a set of input variables as well as set of output variables. So definitely, what kind of learning it is? It is supervised learning. And if you look at the class label is of discrete in nature, that is categorical in nature. DM2 represents diabetes mellitus 2. NGT refers to normal glucose tolerance. So the class label is a categorical label. So since it is a categorical label, definitely it is a classification task. So you have two different tasks that's to be performed for the microarray data. One is gene selection, another one is sample classification. For gene selection, you may have many algorithms are available. Here in this case study, I used to discuss about the correlation coefficient and the mutual information. Mutual information is nothing but the information gain that is discussed in the decision tree. The same thing is you need to calculate entropy, and calculate the condition entropy, as well as you need to based on that you need to calculate the mutual information value. The difference between the two will give you the mutual. So based on the mutual information value, the one which is having highest, which will be selected at the top rows. Likewise, you go for correlation coefficient, which is having higher value. You can choose the top ranked genes. Then you either by using trial and error method, you can find the topmost genes, or at least you can start with the 10 number of topmost genes to be fed into the classifier model. So the classifier model that is planned here is an artificial neural network. Then for this case, so this patient is already the correlation coefficient has been discussed. You need to find the covariance with respect to the corresponding standard deviation. We can simply say whether this is positively correlated or negatively correlated. But based on that value, you can go for the. So here, when you take this case, you look at it, instead of the x1, x2, x3 value, here that label is changed to G1, GI, GD. So that is corresponding gene expression value. See how many number of genes are there. If you look at it, there are 22,283. You cannot give 22,283 genes here. G1 to GD. That is a D here refers to the selected number of genes. So you have to give the input and the same process. You have to go through the hidden layer and output layer, and you produce the Y1 value. Initially, or at the first go, you may find error between Y and the original target. Then you need to feedback in order to adjust the value to V1 and W1. And at one point of time, when this process is going forward and backward, at one point of time, you can find the corresponding output, and then that output can be utilized for the data. So let me give a small demo for the MATLAB code development in order to understand the process. what you need to do is you need to, what are the steps you need to follow is you need to load the data, then you need to identify the gene selection using correlation coefficient, then via neural network you need to do the sample classification. In order to utilize the neural network, you need to divide the data into training and testing. This is what I already mentioned in the machine learning model. Then you need to do the normalization, initialization of the network, train the network, test the network, as well as finally you have to calculate the accuracy. So this is what you need to do MATLAB calculation code. I will give the slide. You can later go through that code. So when you apply the correlation coefficient, see for every gene you have find the corresponding CC value, and based on the CC value you can rank the gene according to the CC value, that 1, 2, 3, 4 like that. So the top ranked gene, see this gene number is not gene ID, and this gene number is the serial number of the gene. So there are totally 22,283 genes is there. Among that 17,645th gene has the maximum value of correlation coefficient. That means it has a higher impact on producing the disease. So likewise, the taken. So here, what is what it did is the top ranked gene. So that is only 10 value has been taken and is fed to the neural network for further processing. That means further classification. And you have to treat the model, and you may get the these kind of output. Let me give you a demo over the MATLAB environment so that you can understand well. Mm. So this is the data. So this is the data. Here you can find the ID here. Here you can find the ID 1007 SIT. This is ID. So totally how many IDs are there? In row wise, you can find a gene. Total 22,283 ID values are there. How many number of columns are there? There are 34 columns. 17 corresponds to diabetes mellitus and 17 corresponds to NG2. Oh, next, what we need to do is, okay. So here is that code. So here you loaded the data. Here you loaded the data. Then here you divided the data into the corresponding cases according to the two groups. Correlation coefficient has been calculated. Then based on that, the training and the testing data has been divided. After the training and testing data, then you have to do the normalization for the training data as well as the testing data. After having done the normalization for the input and output and everything, then you need to create the network structure. So network structure has been created with respect to number of hidden layers, number of output node, what is the transfer function, what is the linear function, everything you need to discuss here. And then you need to train the network. After training the network, you need to test
Excuse
the
me,
network.
sir.
Yeah, yes.
Sir, the screen is not shared, sir. That screen.
Oh,
That
this
PPT
screen is not
only.
shared.
Yes. Sir.
Okay. So I have to share my entire screen. Instead of that, I just shared. Yeah, sorry. I think I need to share the entire screen. Where is entire? Okay. Sorry, here is the data is about. Again, I am saying here is the data. You may find the huge data here. The code for correlation coefficient. So I think I am running out of the time. Maybe the given time was only 2:45. I'm executing this and letterwords. Through my presentation as well as through my material, when the organizer they given to you, they can understand that. So the diagrams and all have come, and again I need to share this screen. Every time I need to share the screen. So this is the way the output has been formed for the network model. There are about 41 iterations. The network has got, you can get it from everything, performance, training stage, everything you can get through this material. I think I will stop this session here. Yes. So you can find many of the micro data analysis related work using these references. These references will be used by for your further research for understanding the different kind of way the microarray data has been analyzed using the machine learning algorithms. So all are very good journals that are published. So is there any query? Maybe I have rushed out by introducing few machine learning algorithms. If you have any doubt, as in the initial session that you can share through the chat window, or you can ask. May I wind up now? Because I think I am running out of time. Ma'am?
Yes, sir. You're audible. Sir, can I ask the questions?
Yeah, yes, ma'am. Yes, ma'am.
Yes.
Because
Yes,
I think I am running out of time.
Yes, my first question is on how feature extraction is performed in microarray data.
Yeah, same thing, ma'am. You are given with that data, which I told that is diabetes microarray data. When it is given, the already in the previous case, it is illustrated about the way in which this CC value is calculated. That formula is there in order to calculate that value. Has been calculated. This value, this R value has been calculated, and based on that R value, that is the CC value or a correlation coefficient value. Here the table shows that for each gene this value is calculated. How this is calculated? Here again, you may have this idea, right? This one. For a simple case, summation x is like this. For this, you have summation xy summation. That formula is written as a inbuilt code, or you can also write your own logic in order to find that value. That thing will be used for every variable. Then that variable has been sorted out based and then ranks are assigned, like I shown here. Ranks are assigned, and based on the rank, either you can go for a one by one way of giving the variable into the ANN model for understanding the data. At a reasonable amount of number of genes, the understanding is good. That means the classification good. You can stop, or you can choose the topmost gene. That is the logic that you need to follow. So only thing you need to apply that formula for calculating the CC value. Based on the CC value, you can assign the rank.
Yeah. Next question is, what are the different methods for adaptive weight updation?
So you want to make the weight updation is to be adaptive. You need to my knowledge goes, you can use some optimization algorithms that can be attached to ANN model, even support vector machine also you can attach. That is can be used to vary the weights. According to different weight parameters, you need to find out the classification accuracy. The classification accuracy can be taken as a fitness value. In order to improve, that is, in order to maximize the accuracy, you can again come to a newer set of weight values, and for a particular set of weight values, you need to fix the best value, and that set of weight values can be treated. So in order to find out the adaptive weight values, to my knowledge goes, you can go for I think optimization algorithm. That is some kind of hybrid algorithm. That's what I to my knowledge goes.
Yeah. One more last question. Is there any diabetics data website which could be downloaded to work on?
Yeah, yes. Actually, the data I have received from one scientist who is working in USA. The same data only I am having, and also I have downloaded one more data from NCBI, National Center for Bioinformatics. There you can get it. Afterward, I didn't go much depth into the diabetes data. Maybe some more websites are also available. So I have downloaded majority of the data from NCBI, National Center for Bioinformatics. There you can find a lot of. So that they have one kind of web portal called Gene Expression Omnibus. There you can take it.
Yeah. Thank you. Now I request Mr. Arvind to felicitate our keynote speaker, Dr. P. Ganesh Kumar.
All right. Good evening, everyone. Yes, I hope you can see me. Yes. So good afternoon. Many thanks to.
Sir, excuse me, sir. Shall I allow me to share my screen, sir?
Sure, please do. Yeah.
Ganesh Kumar, sir.
Dr. Ganesh Kumar, you have to stop your screen sharing.
Arvind sir, please.
Yeah, sure. Okay, so first of all, a huge thanks to Ganesh Kumar sir for doing this session, for doing this wonderful session. I personally learned a lot of things, starting from understanding the machine learning techniques from the basic, right? So whatever content you were sharing was really helpful, and I'm sure it was the kind of live code and everything that you're showcased towards the end will also be very helpful for people to get started. And towards societal changes is something that I totally believe on. Using technology, the IEEE tagline totally stands for advancing technology for humanity, right? So when you talk about problems like diabetes, when you talk about all these real social problems and how we can leverage about technology, I think that's the most important part that all of us will be taking forward. On behalf of this specific activity organized by IEEE India Council Educational Activities and supported by IEEE Madras Young Professionals, I'm truly thankful for doing this session on artificial intelligence techniques to address societal changes. We would like to host you on many more sessions in the future and keep this conversation about such technologies going on. So many thank you, sir. Many thank you for doing this.
Yeah, thank you, Mr. Arvind. And thank you, Mr. Ganesh Kumar, sir. Now I request Ms. Sri Divya. Ms. Sri Divya, to introduce our next speaker, Dr. K. Suganya Devi, NIT Silchar.
Yes, ma'am. Thank you, ma'am. Good afternoon, everyone. It is a great pleasure for me to introduce our speaker, Dr. K. Suganya Devi, Assistant Professor, Department of Computer Science and Engineering, NIT Silchar, who is going to talk to us about disease detection in plants using machine learning algorithms. Professor Suganya Devi obtained her PhD from Anna University at the year of 2014, and she is a gold medalist for her master's from the same university at the year of 2008. Her research interest includes image processing, artificial intelligence, medical image processing, multimedia, and machine learning. Madam has published more than 30 articles in reputed international journals and 21 articles in international conference. She has authored 7 books and 4 books chapters. She was granted with 3 patents. She is an expert in the field of teaching with more than 10 years of experience, and presently she is supervising 9 PhD scholars. It is such an honor for us to have you today between us. Over to you, ma'am. Ma'am? Rika, ma'am, am I audible?
Yes, you are audible.
Okay.
Madam, you got made her as co-host, Sridivya?
Yes, sir.
Okay. Yeah.
Yes.
Madam, unmute your mic, madam. Your mic is muted.
Very good afternoon, sir.
Yes, madam. Welcome. Yeah, please go ahead.
Okay, sir.
You can share your screen.
Okay, sir. 1 minute, please. Yes, my screen is visible, sir.
Yes, madam.
It is visible.
Yes, madam.
Okay. So, happy afternoon to all the dignitaries gathered here. So, at the outset, I would like to thank the coordinator or the convener of this IEEE workshop, Dr. Professor Devraj sir, for giving me this opportunity to deliver a few words on this topic, that is disease detection in plants using ML algorithms. Okay. So, to start with, actually, this is a very well-known Thirukkural, that is Suழன்றும் ஏர்பின்னது உலகம் அதனால் உழந்தும் உழவை தலை. So we can slightly modify this as Suழன்றும் கணினி பின்னது உலகம் அதனால் உழந்தும் உழவை தலை. That is everything. Now all the domain, the system is not, the computer is not leaving any of the domain. It is occupying all the domains, and it is ruling the entire world. So it not only leaves the, now it also enters into the agriculture field also. Okay, so actually, so my area of specialization is, I am from NIT Silchar, and my area of specialization is image processing. Majorly it is image processing, and I am working on medical imaging as well as the video surveillance and this agriculture sector. So everything runs behind this image processing only. So to start with today's, my lecture is session is revolving around these things. That is, to start with, it is the introduction, research avenues in smart agriculture, and sample case studies on plant disease detection, some interesting works, and ended with the conclusion. So introduction, the first thing I want to register here is, actually in all the fields, the system is the machine learning, whatever we may call it as a machine learning or a artificial intelligence or deep learning, anything. So in all the domains, it is easy to, all the domains has adapted it easily, but not the agriculture sector, because there is some drawbacks for adapting the or taking the advantage of variety of technologies that are ruling the world. That is even the fourth industrial revolution. We will call this as a smart agriculture kind of thing, as this industrial revolution. That is industrial 4.0, industry 4.0. So it is not actually all the full thing is not actually went deeper into the agriculture sector, because there is a few reasons for this. The fragmented rural network, the poor infrastructure, and heavy regulatory burdens are the main reasons. Whereas the revenue has been actually the farmers, they are actually producing the products, but they are not free enough to, or given the freedom to fix their prices. So the revenue has been constrained by the market, and the increased disparity between the commercial farming and the small owners are the main concern for this gap. That is the technology and the agriculture sector. There is a big gap is there. So this gap is because of these reasons only. So earlier in the past, that is in the 19th century, just we are having only a plough, and with the help of those things we are doing the agriculture. Then in 1980s, some GMOs has arisen, and from 2008 we are using this GPS tracking machinery kind of thing. That is the all the maximum the labors are replaced by the machinery kind of things. Even for the harvesting also, now and all, we are not depending upon the labors. Earlier we are depending upon the labors. Now we are not depending upon the labors. It is done by the machinery only. So at present, the technology has evolved, and it is getting deeper into the agriculture sector. So because of this, for everything we are having the sensors. To control the water supply, we are having the sensors. That is IoT, no, Internet of Things. With the help of the IoTs, we are managing the agriculture field from sitting in one place or even in the remote place. We are now controlling the agriculture field with the help of the IoT. So the output of the IoT, the input will be the sensors, right? So we will be placing the sensors wherever it is necessary, like crop monitoring or irrigation or pesticide, or even the soil monitoring. All this, even for sustainability, we are using the sensors. But output of this sensors is nothing but overwhelmed data. So now what to do with this data? So the farmer is getting confused what to do. We are getting day by day tons and billions of data, but what to do with these data? So in future, actually, if something could be done with the insight into the data, we can do the miracles in the agriculture sector too. Right. So how we actually learn? We learn everything from our childhood with the help of the experience, right? We will be practicing A 10 times or 20 times. Then we will recognize that this is the letter A. This is because of the experience. Say, for example, if we touch the fire, we will tell that it is a hot, right? So that is based upon the experience. But how the machine will learn? The machine will learn for the experience can be replaced with the help of the data. So if we feed the data, then the machine will learn from the data. Okay, so if you feed small amount of data, the accuracy will be small. If you feed the large amount of data, then the accuracy will be large because of the learning capacity will be improved. Okay, so now as I said in the earlier slide, we are because of the technology, we are getting more and more data from the agriculture field. So we are going to feed these data and we are going to solve the problems of the farmers, or the what are the existing problems that is prevalent in the agriculture sector. We are trying to solve with the help of the machine learning and AI algorithms. So actually the common, we can broadly divide the problems in the agriculture sector into 5 categories. Okay, so the first comes is the crop disease infestation. Crop disease infestation is nothing but diseases. That is the disease may be due to the stress, or due to it may be due to the pest or insects, right? So this is the crop disease infestation. The next is the lack of storage management. Here, I think so in the last flood also, these meme has been prevalently I have seen in the media. That is மழையில் முளைத்த நாத்துகள் அலட்சியத்தால் அழுகும் நிலையில் 6000 நெல் மூட்டைகள். This is nothing but the lack of storage management. So this is due to abiotic factors as well as the biotic factors. And the pesticide control. The pesticide control is the important thing. Why? Because the excess of pesticide, it not only affects the plants, but it also affects the human and economy of the nation. So there also we need the research has to be carried out in the pesticide control also. And then the weed management. The weed management, as we all know, in the agriculture sector, the weeds are the quite common thing that we can find in any agriculture fields, right? So the methods that can be used for this is chemical method. Otherwise, we can go directly by plucking the weeds, that is a physical method, or a cultural method, or we can go for a biological method. That is with the help of another insects or some other thing, we can eradicate the weeds, right? So for this also, we can apply we can put the sensors that can detect the normal crop as well as the wheat crop. And after then, once the wheat crop is, for this actually we need the image processing. So once the normal crop and the wheat crops are identified, then we have to go for the wheat control tools, and then we can manage the weeds. So coming to the last, that is lack of irrigation and the drainage facilities. The lack of irrigation, both are actually controversy. Lack of irrigation is the, say for example, the geographical region that is entirely depends upon the seasonal, that is rainfall. So there they might have a sparse rainfall, or they might have a seasonal rainfall. So there, to sustain the agriculture, they need the irrigation. So in the same way, on the other side, suppose there should, even our Tamil Nadu also, it is depending upon the irrigation only. Suppose in case of heavy rainfall, what will happen? All the agriculture fields, it will be fully flooded. If it is fully flooded, there should be proper drainage facilities to drain the excess water from the agriculture field. These things has not been noted anywhere. So because of those things also, both the farmers as well as the economy of the nation, they are suffering a lot. So lack of irrigation and drainage facilities has also to be considered for the research. So in whatever, I have told you the 5 major problems in the agriculture field. So in every category, the artificial intelligence as well as the machine learning has penetrated, and with various algorithms, and we are evolving with various algorithms for each and every category. So this is some sample ANN, that is artificial neural network in the agriculture. But you can see that this COMAX is nothing but a cotton management expert group. That is mainly, it is developed by Lemon in 1986 itself. You can note this is from 1986, and this is especially for the cotton plants. This will work out for the cotton plant. And likewise, this Cotflix is some improvement has been made by the IBM microcomputer, and This ANN has been developed. This Soya Grow is nothing but for soya bean, and Prithvi is for soya bean that uses the MATLAB. This uses the growth model, whereas this uses the MATLAB. This Prithvi is the 2013 in Prakash et al. They have developed this Prithvi, and Pomi is for apple fruit, and Singh et al. Is for maize, and Arif is for paddy fields. So it is not limited to this, but so many artificial neural networks even now they have shifted everything to the deep learning. So there they are creating so many models exclusively for exclusive plans. From say for example, this is a T for India. From India it is T and modified TPEST. TPEST and for modified TPEST are there. So they uses this for detecting the abnormalities in the T plants, right? So likewise for every crop we can take any crops. Still all the crops is having some loopholes, and they are the common loophole is we are having a model, but those model is not detecting all the diseases of a particular plant. This is the common thing we have come across in the agriculture sector. So the one point is it is not specific to the plant, and it is not specific to the disease. The third problem is there is a lack of data set for the particular plants. We cannot have the data set, enough data sets for the particular plant. That is the major challenge in this case of the agriculture field. So this is our first case study. This is done by one of my scholar actually. She is doing the research in this legume plant, that is the peanut plant. So here the major problem is it is a oil seed and it is contributing major portion in our economy, but the fungal disease such as leaf blight, leaf scorch, pepper spot, alternaria, phimopsis, phoma, so that is in particular there are 10 diseases are there. Even you can find these diseases in TNAU website also, Tamil Nadu Agriculture University website also you can see these things. But the problem is, even in that website, you cannot find any data sets for these. You can find if this is like this, it is affected by the particular disease. Say, for example, alternaria, it will give the suggestions also. But you don't know whether, suppose you are giving a live leaf or live plant in as a photograph, it will not suggest you what it is actually. So we had a thought of developing a model that can recognize the groundnut plant leaf diseases. Actually, plant diseases is entirely different. That is, even the stem rot, the disease can be affected in the root and stems also. We have taken only the leaf. That itself is it took around 2 years for us to complete the things. Why? Because there is no data set for this kind of plant. So what we did is, these are the actually different diseases, that is alternate. You can see the difference in all these diseases. Here you can find the yellow burns, and here it is fully burnt. This is called as a Pestalopteas. And the Conifera, it is the leaf itself will be burnt actually. Here bud necrosis, you can see a bud-like projection in the leaf surface. And here this is a ticka. This is a healthy leaf. The healthy leaf will be like this. And the pepper spot, as the name implies, the pepper is nothing but it is like spraying the black dots on the leaf. Rust is like, it is like a red color. As such, the rust will be there in the iron, no? Like that it will be here. It is called as a rust. And this is Pilastica. And this is early spot and late spot. This is the late spot. Early spot, it will be just starting. And this is the fully done. That is, it is a late spot. So these are the common diseases in the groundnut plant diseases. So what we had thought is, actually this is the problem. One is, there is already a model is there, but that model is not giving that much accuracy, and also it is not detecting all the diseases, right? This is the first thing. And the second thing is, there is no enough data set for these, especially for this groundnut leaf diseases. So what we did is, we have collected the data from Virudhachalam research region, that is a regional center is there. So we have collected the data from there. We have in person, we went through proper channel and we got the data set. Data set means we have to capture the photos. Why? Because there also they didn't have the data sets. So in that also, what is the problem is we cannot get all the diseases at a time. So we have to then and there we have to monitor every diseases. Okay, so that am I audible? Hello.
Now audible, ma'am. Now audible.
Audible. I think so. My screen is visible. Otherwise, I have to share the screen again.
No, you have to share again, ma'am.
Okay, okay. I have some network issues. I think so. I am outside. Sorry for the inconvenience.
No problem.
Okay. Now the screen is visible, right?
Yes, yes, ma'am.
Okay. Okay. So I think so. Here I have left. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. Thank you. So the thing is actually what we have did is we have find the feature the problem we have identified is I am directly showing you the results. Actually here this is actually the input image. We have taken this as a rust image. For example, I am giving here the rust image. This is the leaf, it is having the rust. So here what we have did is we have fine-tuned from the first instead of directly going into the algorithm. That is what we have done is, so here this is for we have modified the algorithm for the feature extraction, that is first feature detection, then feature extraction, and then we have used the we have moved for the classifier. So in the feature actually from the start, that is the detection is the most important thing. We have to detect the important features, and from that important features the meaningful features has to be extracted, right? So the first thing is feature detection. Okay, so the feature detection, we have implemented the fast features, eigen features, and Harris actually it is called as a Harris corner detection. Okay, Harris corner detection. Here the fast features, it is giving a less samples, but it is not detecting all the rust spaces. Here you can see, I think so my pointer is visible. Here it has left some of the rust space itself. But in the eigen features, what happened? It is giving the features out of the box, right? So it is giving more features. It is very difficult for us to extract the important features. And here the Harris features, with the help of this we can detect the here the Harris, it is giving 211 features for the image 1, and for the image 2 it is giving 1159, and for image 3 it is 183, and the image 4 335. And this is the comparative results of those things. So here we have identified that Harris corner is giving a best feature detection, and these are the simulation results, and we have combined this with the KNN, that is K nearest neighbor algorithm, and we are doing the simulation with the help of this. So in this we have taken 250 images. We can collect only 250 images, and 45 denoised images are trained with the KNN algorithm or useful in pattern matching. Remaining 205 images were used for testing the trained network. So here this is how we have implemented in the MATLAB regulation, that is R 2018A, and it is here it is identified. We have identified the early spot accurately, and the late spot also, and it is the blight, and it is the rust. So here the problem is we have done only, we could accurately we can detect only the 4 diseases what I have shown, the early spot, late spot, rust and blight. And so what we have done is, so next we have improved our extraction algorithm. Instead of detection algorithm, we have included the extraction algorithm. For that, we have gone for HOG, that is histogram of gradient algorithm. So for a better feature extraction, so there along with the ANN, we have got these results. That is, here you can see, this is with the help of the HOG descriptors. This is the Harris features. Once the Harris features has been detected, from this the features are extracted with the help of the HOG descriptors. Then our accuracy improved a little bit after this. So after then what we have did is, we have combined this with the KNN, and we have compared this with the ANN and KNN. So there we got that as the classification accuracy is, for the ANN it is 91.2, and that is for learning ability is 97.2 for the ANN, and for this KNN it is 94.8. Okay, so the next is, after this what we have did is, here the problem is still we are not able to identify all the 10 diseases. That is the one thing. And then automatic classification of groundnut leaf diseases has not been done. We have to fine tune the parameters of the algorithm, say for example HOG or Harris corner detection. We have to fine tune the algorithm for detecting the for extracting the features. So what to be done for this automatic classification of groundnut leaf diseases? Classification is also automatic, so feature extraction has also to be done in automatic way. So we have shifted our entire thing to deep CNN, that is the deep convolutional neural network. So here we have collected the plant village data set as this. So here we have somehow we did the data augmentation kind of thing, and we have managed the data set to 6,400 numbers. That is the 6,400 images, and 6,400 images was there. After then, we have classified the 4,600 images for the training and 1,800 images for the testing purpose. So with the help of this, we could detect all the 10 diseases of the groundnut with help of this deep CNN. So the deep CNN is like this. So we have used 7 layers here. The convolution layer and pooling and max pooling layer, fully connected layers. So we have used 7 layers, and for this actually these 3 things has to be done. That is the depth parameter, the hyperparameters such as stride, zero padding and depth are considered for output volume size. So the depth parameter is here we have taken the number of neurons present in the layers are managed by the volume output depth. And the stride parameter, this is approximately the spatial dimension distribution such as the width and height of the depth columns was managed. And the zero padding, obviously you people know, that is the convolution is the major operation in the image processing. So here this is the convolution kernel, and this is the given image. So we are convoluting here, and you are getting this convolution. After the convolution, the results. So here, how suppose say for example, this is the matrix, means you cannot this have for convoluting this first pixel, you cannot map the kernel as such. So that needs the zero padding all the corners. So once the zero padding is done, then we can go for the convolution. So once it is done, though these are all the 10 diseases we have identified. We have identified in this. So here, Alternaria leaf, Pestaloptiasis, paper spot, bud necrosis, late leaf spot, tica, Panophora, Pelostica, and rust diseases. So this is the data set trained, and the data set testing is that our CNN model is here. So it is classifying the disease accurately. So I'll show you the confusion matrix we have got here. It is. So here the number of images, 189 images. It has Alternaria leaf. The 189 images were accurately classified, and bud necrosis 597, and rust. It is a quite common in not only in this rust, early spot, late spot, and blight. These are common diseases in majority of the plants. Say for example, Another scholar is working in Oryza sativa. Oryza sativa is nothing but your rice plant. Okay, in rice plant also the sheet, blight, and the rust. These things are common in rice plant also. And in tomato, these things are common. And say for example, even in the vegetable plants, vegetable plants. So all these things, these are common in all the vegetable plants also. So here, this model can be adapted to some other models, even for the sugar cane. It can be, we have tried it for the sugar cane also. It is giving the good results. So this is our confusion matrix. And this is the early part. This is A stands for nothing but the Alternaria. And this is the late part. This is the early part. So it is giving 99.85% accuracy with detecting 186 images, right? So the next case study. So here, the thing I want to register here is it's nothing but you start from the base. That is base in the sense directly the machine learning algorithm or so many models are available in the open source. But directly adapting the model, and you don't expect that it should give you very good results for our problem also. It is not like that. So you have to fine tune from the ground. So go from the feature extraction, feature detection, feature extraction, and then for the classification, then you concentrate on your machine learning problem. And in the previous session also some questions has been asked regarding the updation of weights. The updation of weights, you concentrate on the natural inspired techniques like swarm optimization, that is a particle form swarm optimization, or any swarm intelligence techniques like fish optimization or cat swarm optimization kind of thing to update your weight automatically. Okay, that is the adaptively. Okay, so here also the same thing. And still I have though this much thing we have achieved, still the loopholes are there. That is, in some cases, in a same leaf, we can identify both the early spot as well as the late spot. In some cases, it may happen. So when we are giving the input as the leaf that is containing both the early spot and the late spot, that is multiple diseases, no? If a leaf is affected with multiple diseases, it is failed to detect the same. So that can be taken as a next research. Okay, likewise this is the common for all the, you can take any plant and you can start your research. The thing is, you have to make ready of the enough data sets, and then you try to identify the diseases individually, and then you go for the multiple diseases also. These are all the something on this particular area. So the another thing I have told you, that is the case study on Oryza sativa. These are all the different diseases based on seed, based on foliar fungal disease, based on leaf, and based on grain also. Even the rice, that grain is also having the diseases. Okay, so you can take any one and you can concentrate to find, you can do the research on finding all the diseases in the particular seed alone, or in a fungal disease alone, or in a leaf alone. That itself will lead to a big research. Okay. So these things we tried to find in the rice plant, that is rice blast, sheath blight, and sheath rot. And this is not limited to the research gaps, are not limited to the same. There is huge scats of Oryza sativa image data sets. They are concentrating on the particular diseases, not all the diseases like rice blast or a brown spot. And another thing we have taken the consideration here is, we have done all the steps from the start, and the last thing we have concentrated is auto weight allocation, that we have achieved with the help of the different optimization techniques. And this is plant stress management system using machine learning. And here these are some interesting examples. That is the blue liver technology. It is mainly used for weed control, and this is nothing but your smart sprayer, and this is the weed killing robots. They have designed this robot for weed killing, and this is a smart sprayer. This is the world first smart sprayer for the pesticides. So these things, so with the help of the sensors they are doing, it is working accurately with the help of the data only. So there comes again the machine learning part. So the machine learning part is not only dedicatedly, it is not given to CSE people alone. So to have very good thing in agriculture sector. All have to give hand. Say, for example, this robot has been designed by the mechanical engineer. So the sensors has to be implemented with the help of the instrumentation or otherwise the EC people, and then the algorithm part or the handling of the data that could be done with the help of the CSE people. So it is not only it is not dedicatedly given to the CSE people, but it is for all. That is, it is an interdisciplinary research only. The solving the problems in the agriculture sector is a interdisciplinary thing only. So this is the harvest CRO robotics. It is for crop harvesting. Why? Because in Germany, so nearly 11,000 acres of strawberry will be there. So there you cannot imagine. You just imagine how much labors are needed to harvest those strawberries. So they invented what they invented is they invented this harvest CRO robotics for crop harvesting and driverless tractor, automated irrigation system. You can even now everyone is having the smartphone. In the smartphone, you just go to the Play Store and download the Plantix app. This Plantix app is what it will do is, if you take a photograph of it, that is the options will be there. So if you take a photograph of any plant, it will tell whether it is a normal or whether it is affected with any diseases, all kind of things. So they actually though they are from Peat companies, Peat from Germany, they have developed this Plantix, but they have implemented that Plantix in the Andhra Pradesh only. So they are taking the data from us and they are doing the things there. But we are having enough data here, but we are not doing the things here. That is research in the agriculture sector. So this Plantix app is a very good app, but whatever the shortcomings I have told, no, those shortcomings are there in the Plantix app too, right? So then monitoring crop health and sustainability, and the drones. Obviously, we people know now we can take the photograph of the agriculture field. No, we are collecting the database with the help of these drones only. And last, this is my winding up note. That is, though the technology has evolved like anything, it will never replace a farmer's intimate knowledge of his land and his resources. But it allows us to prioritize and become better stewards of the land and our resources to be more efficient. Okay, so never the technology will replace an exact farmer, but it can aid us in doing the things in a better way. So these are some identified areas of enhancing the agriculture sector. That is agriculture crop conditions, weather, climate, ecosystems, and intelligent robots in agriculture, and control of greenhouse. So AI can be appropriate and efficacious in agriculture sector as it optimizes the resource use and efficiency. Next, it solves the scarcity of resources and labor to a large extent. And adoption of AI is quite useful in agriculture. AI can be technological revolution and boom in agriculture to feed the increasing human population of world. AI will complement and challenge to make right decision by the farmers. So with this ending note, I am ending my session. So these are some references. Thank you. Thank you for your patience.
Thank you, ma'am. We have one question from the audience. How satellite imaging will be helpful for identification of suitable soils for crop production?
It's a nice question, but so regarding if it is a satellite images can be used for identifying the crop health and sustainability, but in case of soils of crop production means we have to go with the distance matters. The satellite images, that's what I am telling. Instead of satellite images, you can go for the drone images. Otherwise, if you are going for the satellite images, the distance matter. That is, the distance should be at least to say some 500 meters to 1 kilometer only you have to take. The more than that means the soil capacity we cannot identify. The for satellite images, once the word image comes, the soil fertility cannot be analyzed directly with the help of the satellite imaging. If it is a nature, that is with the camera, even then also to some extent we can identify the soil capacity, that is the fertility of the soil. and through imaging, it is to my concern, it is not possible. How
next
irrigation
question.
is improvised
Yes.
using ML models. So the irrigation can be improvised using the ML models means you will be placing the sensors in the agriculture field. It will sense and it will tell you at what time you have to water your plant, right? So those data will be collected. So once the sensors, what is the work of the sensor? It will be sending the data fully. So once the data are collected, you have to design a good machine learning algorithm to in a efficient way that at the right time, even it will not miss the seconds. At right time, it has to give the signal to the sensors to activate the irrigation process.
Thank you, ma'am. Now I request Dr. Vijayalata to felicitate Dr. Suganya Devi.
Shall I share my screen, ma'am?
Yes, I have stopped my screen.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Dr. Vijayalata madam. Vijayalata madam. Otherwise, Dr. Rajeshri madam.
Yes, sir.
Kindly honor the speaker, madam, Dr. K. Suganya.
Yes, sir. Yes, sir. So it's a privilege, ma'am. It was very, very informative. And thank you so much for joining us. On behalf of all of us at this workshop organizers. So I would request you to kindly accept a small token of appreciation, ma'am.
Thank you, ma'am. Thanks a lot. Thanks for the opportunity, sir.
Thank you so much, ma'am. Looking forward for future strong association with us.
Sure, ma'am. Sure.
Thank you.
Professor Devraj sir, thank you, sir. Thanks for the opportunity.
Thank you, madam. Thanks for the nice presentation.
Yes, yes, sir. Thank you, sir. Shall we leave, sir?
Yes, madam. Yes, thank you.
Thank you. Thank you all.
Thank you, ma'am. Our next session is on implementation of machine learning algorithms using Python. Will be provided by Dr. Annie Utra, SRM Institute of Science and Technology. Now I request to introduce our speaker, Dr. Annie Utra.
Am I audible, madam?
Yes.
Thank you. Good afternoon, everyone. It is my pleasure to introduce Dr. R. Annie Utra. Dr. R. Annie Utra is working as Professor and Head in the Department of Computational Intelligence at SRM Institute of Science and Technology. Additionally, she was serving as Adjunct Associate Teaching Professor in the Institute for Soft Research in the School of Computer Science at Carnegie Mellon University, Pittsburgh, USA from 2013 to 2018. She has published more than 40 papers in international, national journals and conferences. The awards she received includes IIT CLN Women Engineer 2016-17, Outstanding Reviewer Award from JNCA elsewhere, Recognized Reviewer from JNCA elsewhere, Best Teacher Award in 2006, etc. She has been served as a visiting professor in Henan University of Economics and Law, Zhengzhou, Henan Province, China, from year 2018 to till date. Her scholarly and teaching interests design and analysis of algorithm, theory of computation, wireless sensor networks, machine learning, and data analysis and IoT. With this brief introduction, I am inviting Dr. R. Annie Utra to deliver the lecture on implementation of machine learning algorithms using Python. Thank you very much for giving me this opportunity. Namaste. Over to you, madam.
Thank you for the introduction. Hope my screen is visible.
Yes, ma'am.
Yeah. Very good afternoon to everyone. And this session, in today's session, it is almost the end of the day. You might be very tired, but then you can do some kind of hands-on this session, machine learning using Python. So before moving into what is into the implementation of machine learning in Python, I'll just introduce what is machine learning. So we have nowadays, in the current era, artificial intelligence is the buzzword nowadays. And this artificial intelligence, under artificial intelligence, we have different domains. We have machine learning, deep learning, and natural language processing, neural networks, and so on. So these are some of the subdomains of artificial intelligence. And what is really artificial intelligence is we are trying to create, the computer scientists are trying to mimic the human brain for the system. That is what artificial intelligence is. So we are trying to create how the human is behaving that should be adopted in the machine also. That is what artificial intelligence is. So the human being they will be able to identify some kind of objects. They'll be able to recognize the objects and so on. The same way we are trying to make the system also to recognize the things, objects, and so on, and to predict something also. So this is what we are trying to do. And that can be achieved through machine learning as well as through deep learning also. So the difference between machine learning and deep learning are, if we want to have some heavy additional resources, then we can go for a deep learning. And if we want to perform in one shot, if you are not able to classify the results, then you have to proceed with multiple layers. That is where you have to move on to the deep learning also. So in today's session, we'll have some kind of hands-on for implementing the machine learning algorithms using Python. And the assumption is, I assume that the participants are good with their basics in Python as well as basic knowledge in machine learning. So with that assumption only, I have prepared these slides, and the contents goes like this. We have the data analysis commands on Python and some of the visualization techniques, and we have pre-processing. So in the previous session, the presenter was talking about how to do some kind of analysis on the agricultural things. So how to detect diseases and so on. So the main thing you have seen as a pre-processing thing. So one of the pre-processing, we can see how to handle the missing values. So when we have missing values, the computer cannot able to properly learn the things. So what is machine learning? We are giving a historical data to the computer, and the computer will learn the things based on the historical data. And after learning, then if we are giving some kind of samples to that, it will be able to identify, or it will be able to predict or classify based on the things which it has learned already based on the historical data. So this is what we are trying to do. So in that case, when we are feeding the data set to the computer, it should be full. There should not be any missing value. So that is why we have to do some kind of pre-processing. So there are so many pre-processing techniques are available. Even dimensionality reduction is also one of the pre-processing techniques. But here what I am telling missing value, because how to replace the missing value when you have some of the entries, because when you are collecting, say for example, some of the data are available online. So if the data are available online and if it is already pre-processed, then it is well and good. But sometimes we will be able to collect our own data for our specific applications. So if that is the case, then you can use some kind of sensors, or even you can use crowdsourcing also. So you can just float out applications, and then through the app you can collect the data. And when you are collecting the data, either as through the app, or you can float out some kind of papers to collect the information. And all everyone who are filling will not give all the data. So that is where you have the missing values. When you have a missing value, how to replace those fields? That is what the data pre-processing is. And then we have the classification also. And the KNN, how to implement KNN classification in Python, that is also there. And finally, clustering. I am not sure whether we can complete all these things in this class. So how much is possible, I can do that. So some of the some of the libraries which are used for data analysis in Python are, these are the some of the libraries we have. One is NumPy, SciPy, and Matplotlib, and Pandas, and scikit-learn. So these are some of the libraries which are available for data analysis in Python. If it is NumPy, this is a numerical Python. So that is what NumPy is. This is the short form of numerical Python, and this will represent the arrays, and convert the arrays into some kind of flattened array and so on. You have to resize the array and you have to transform the array. So there are so many ways in which, because what we are dealing with is we are dealing with data sets, and that data can be converted into an array, and you need to have some kind of manipulation with the array in Python. That is why we you can include this kind of NumPy. So the basic array operations as well as the linear algebraic functions and Fourier transforms, all these things will be included in this library. And one more thing is SciPy. This is the scientific Python. It is just the advanced version of NumPy. So you can do something advanced with SciPy library. So what is library? You will be having so many functions under these, and all these functions can be utilized. And one more thing is Matplotlib. This you might have used in MATLAB also. So we have a variety of graphs, and if we have two graphs, then you can import this library. And Pandas is one of the key library where we have all data structure operations and manipulations are available. So if we want to perform any kind of data structure kind of operations, we can use Pandas. So in the later slides, I can show you some examples. What are the functions which are available in Pandas also. And scikit-learn is a machine learning. It is specifically for machine learning, which is built on top of this NumPy, SciPy, and Matplotlib, and so on. So, and these five are very important. And other than that, you have some kind of statistical model and Seaborn, Scrappy, and so on. So these are specific for some kind of application. You have web crawling, where you can fetch some kind of information from the web. So if you want to deal web crawling, then you have to go for Scrappy. So this is these are the different libraries which are available. Depending upon the application, you can choose any one of the library. So before moving into the data set which we are trying to see, I'll just show you some kind of data sets which we are planning to use. So I think already you all might have received some kind of data sets. So I can show you some data sets also. So we can classify we have two different, the major classification of machine learning is, one is by using, one is a supervised method, and another one is unsupervised method. So what is supervised method? If you have any, if you have the classification labels, then we can call that as supervised. And if you don't have the classification labels, then we call those things as unsupervised. So these are some of the data sets which I have shared. One is the user detail, and another one is the iris data set. So this is the user data set. So here, if you have seen, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 different features are there. So what do you mean by 8 different features? We have 8 axes. So all these things are considered as axis. This is one axis, and the first name, last name, all these things are axis. And these, every row is called as a sample or example or a data point. So all these things together, ID1, first name, last name, age, BTC, relationship, gender, all these things will define a point. So we have either you can have two-dimensional data, or you can have three-dimensional data, whereas what we have here is 8-dimensional data. That is what we say that we have D-dimensional data. If you are mentioning it in general, we can say that as D-dimensional data. Every data, all these things are called as the feature. So this is every column will represent the features, and these features will decide on the dimensions also. And every row is called as a data point, or it is called as sample or example. So in this case, we are not defining what it is. Say, for example, all these things together, we can define that person as Roberts. So if the ID is 1 and his first name is Buki and last name is Roberts and age is 20 and BTC is 5, and all these things are given, then we can define him as a Robert. Whereas here there is no such classification, or there is no grouping also. So either you can group this as in terms of income, or you can group this in terms of gender and so on. So this is called as there is no target variable. So all these things we are defining something, and this point represent what that it is not specified. So if this is the case, that we call it as unsupervised. Suppose what is supervised, the data points will be defined with a target variable. So here is the iris data. So this iris data is not the iris which exists in the eyes. It is with respect to a flower. So the flower, again, we have the identifier is given, and the flower can be classified in terms of sepal length, sepal width, petal length, and petal width. And finally, the flower will be classified. This is what the target variable we call that. This is the output variable, we can say. So here we have 3 different types of flowers. One is Iris setosa, and another one is Iris virginica, and another one is Iris versicolor. So how it is being classified? It is being classified using the sepal length, sepal width, petal length, and petal width. So this is what the classification. And we have all these data sets are available in online also. So we don't have, this is a processed data set. So based on the difference between the sepal length and petal length, as well as sepal width and petal width, we are doing this. So we are doing this with, so this is what we are doing. This is called as supervised data. So what is supervised? Every data point is defined by a target variable or by a output variable. So if the output is available, then we can say that as this data point is considered as a specific target point, which is in this particular example, it is Iris setosa, or it can be Iris virginica, and so on. So what the data set is, this is about the data set which we have seen. So iris flower, this is the iris flower data set which was framed by Fisher's. It is also called as Fisher's iris data set because it was framed by the biologist Ronald Fisher in 1936 itself in his paper. So these are the actual pictures of the flowers. This is Iris setosa, and this is Iris versicolor, and this is virginica. So just see this one, it is all very similar, same kind of family. The flower belongs to the same kind of family, but the difference, only difference is it is based on the sepal length, width, and petal length and width. You can see all these things. So being a human being, just by seeing this kind of nature, our brain will record all these things based on the height, width, and everything. So we don't intentionally do that, but we have been created such a wonderful creature by the God. So that is why we are able to identify what is this flower automatically. But we have to create such kind of environment to the computer also. So what you have to give enormous amount of data, the historical data we are giving, and the computer will learn based on that. And finally, if we are giving any kind of input to that, then it will be able to identify. So this is what we are supposed to classify, and this data set only what we have seen in the data set, we have seen this one. And now we can directly go to the hands-on, move on to the hands-on session. So how to read the CSV file using a pandas object. So in Python, this pandas library is very, very important, and NumPy and Matplotlib. So these things I told you. So the pandas object will create, you have to create, this is import pandas. Import is keyword which is used to import the libraries in Python. So import pandas as PD. Every time either you can use pandas or you can use, just for simplicity, we are making pandas as PD so that you can refer whenever you want to refer pandas, you can refer PD. The same way, NumPy can be shortly denoted as NP and matplotlib.pyplot. So only in pyplot we can plot something. So if we want to use this pyplot, then you can, that can be renamed as PLT. So wherever you are calling the function of matplotlib.pyplot, instead of writing the entire thing, we can call the smallest thing PLT. And how to read the data set is, we'll be having the CSV file. So the Excel file, if you have the Excel file, you can create a save as, give save as, and then save it as .sl CSV. So this is comma separated values. It will be separated with in terms of commas, so that it is easy for us to read the CSV file and it can be converted into a data. So all the files, whatever content we have, that has to be converted into a data frame so that it is the Python will be able to process those data. So the first step what you have to do is you just read the CSV file and then we have to convert it as a data frame. So this reading the CSV file with the PD will convert it into a data frame. This is just an object only. So whatever you are creating in Python, that will be created as an object. So df is equal to pd dot read CSV. This is the standard function which we are having inside the pandas. So pandas, we have renamed pandas as PD. So you can say either you can use pandas itself here or you can use PD. So PD dot read CSV, and then in where you are, if you have some anything in the local drive, then you can use this local drive. I have saved in this particular path my iris data set. I have saved in this path, so I can show you that. So this is what my path is, right? So I have this is what the data set I have. So you can copy this path where you have saved the data, and that can be used over here. So iris we are reading, and that will be saved as a data file. And one more thing is you can use a Google Colab also. Suppose if you don't have any Python currently, if you do not have any Python ideally, then you can use the Google Colab also. And one more advantage of using Google Colab is it will be it is with some certain amount of GPU. So the execution speed of Google Colab is much high. So if you have a heavier data set, then you can go for a Google Colab also. And I can just show you how you have to execute. And the implementation, suppose if you have to implement the Python, then you can just Google Python download, and python.org will be the first link, and you can go to you can download depending upon the system configuration. So if your system configuration is 3264, accordingly you can download the version, and the latest version is 3.9, and 3.9 will support the Windows with more than 7 only. And once it is done, again, if you have you can type here as Python. So when you type Python here, this Python IDLE will come. So if you just click on to Python IDLE, the Python IDLE will open. So this is the Python integrated development environment. So IDLE is integrated development environment, where you can create some kind of new files you can type in, or you can open the new file also. And when you are executing the new file, so these content I have shared with you also. This is what this is how you have to read this. So already this read csv.py. Python files will be saved in terms of .py. So the main thing is, if you have to do some kind of processing for data analysis, the first thing which you need is pandas and then NumPy. And if we are doing some kind of graph plotting, then you have to go for matplotlib.py plot also. But here we didn't use any plotting as such. So this is a simple file reading, and these things, this pandas, NumPy, and matplotlib, what you have to do is you have to install it first. So you can check where Python is available in the command prompt. You can go to the command prompt, and this is where my Python is saved. So again, you can check with the DAR, and we have something called as scripts. So you can go to scripts also. And inside scripts, if you just list out what are the things that are available in scripts, we have something called as pip, right? Pip.exe. So pip install is one of the function where you have to install all those things. So these are all the special libraries. You have lots and lots of libraries available in Python. So whatever libraries you need, those libraries you can pip install here. Okay, so the command here is pip install. And then whatever you want to install here, if I want to install pandas, then I can say pip install pandas, but I have already installed. Suppose if you are just entering pip install pandas here, but you should ensure that the folder, which the current folder or the current directory contains pip.exe. So in that directory, from that directory, you have to give pip install pandas, and if you press enter, then it will enter, it will run complete, it will take all the necessary plugins from the internet, and it will be installed over here. So this is how you can install all those things. You can install pip install pandas, NumPy, and matplotlib, all these things. So under matplotlib, whatever functionalities are there, all the libraries will be implemented for you, so that it is easy for you for execution. So this is what our first program. So what we have done is, we are reading a CSV, and I have taken the file from my local drive. So I have a D drive in my system. From the local drive, I have taken a data set, and that is read as a data frame. And now these are some of the basic commands which we have, head of df dot. So now the rest of the manipulations can be done by using the data frame object. So this is the instance which we have created. With this instance, you can use the rest of the functionalities. With the file name, you can't do that. That is reading the file, and that file content is being converted into data frame, and we are reading the content. And content df.head of 10 will display the top 10 values, and df.describe will give you the description about the data set. And description in the sense, what is the count of every column, and what is the minimum value, what is the maximum value, what is the quartile. We have something called as first quartile, second quartile, and so on. So those values will also be specified. And suppose if you have to specifically find out some kind of mean, then that column name can also be specified here. So df, and here you have to, within single quote, you have to specify. Then you can call the function mean. And then one more thing is, we have mean axis is equal to 1. So if axis is equal to 1, that means axis equal to 1 represents rows. So row wise, it will calculate the mean. So what we are calculating, so what is df now? This iris data set, what we have here, this is read into df, and we are calculating the mean for every row. So that is what called as axis is equal to 1. You can make axis equal to 0 also. If axis equal to 0, that represents column wise. So column wise mean will be calculated, all columns. Even if you have 100 columns, that means even if you have 100 features, it will calculate all mean of all the columns. So that is what, this is a generalized way. If you want to specify some specific thing, this can be done. So we can run this one. So the same program I have given you, copied it in the Word as the first exercise, I guess. Or yeah, no, this I didn't give you. You can just type this one. So you can download the Excel files, CSV file, which is shared and you can store it in any of your local drive, and then you can type in these comments so that you can do this. So if I run this, you can run and you can check what is the answer. Yeah, so this is the answer we have. So initially head of 10, so it will display the top 10 values, and the next one is description. So description will give you all the description about all the features. So what is the count? These are the descriptions we have: count, mean, standard deviation, what is the minimum value, and this is first quartile is what is the first 25%. Out of the 25%, what is the average, and 50%, 75%, and what is the maximum value, and so on. So this is what this will be given for all the features. So we have how many features? One is ID and sepal length, width, petal length, and width. So this is what is given. And the mean, yeah. So yeah, the axis for the mean is given. We have given the mean as, so this is the answer for the this one. We have print of df sepal width dot mean. So this is only for the sepal width. So you can cross check sepal width here. What is the mean here? The mean is 3.05400. So the same value we are calculating separately also, the same thing is coming. And then this axis, you will be having 150 values, because since it is axis is equal to 1, it will give you the mean of every row. So how many rows we have, the number of rows which we have is, that is what the IDs we have 150. So all these 150 values we have. So for all 150 values, it is calculating the mean. But generally we won't calculate, that depends on the application. Sometimes you may want to calculate the mean of mean row wise. Sometimes you may want to calculate the mean column wise also. Say for example, if it is the student database and the students marks, the student wise average, if you want to take, then you can go with axis is equal to 1. Suppose subject wise means, then you can go with axis is equal to 0. So if I say axis equal to 0, then this will give you the column wise mean will be given. So you can save and again you can execute. Yeah. So the column wise is mean is given over here. So for the mean, for the column ID, this is the mean and so on. So this is your first program. You can try this program also. Should I wait to execute? Any doubts? I can clarify, or I can move on to the next one.
Ma'am, is it the same line that we have to type in Google Colab also?
Yeah, the same thing. Yeah, no, in Google Colab, uploading is little different. So I can tell you how to do it in Google Colab also. Yeah, so this is what you have to type it in Google Colab, because in Google Colab it is the Google's thing, and we are doing it in the cloud, Google's cloud we are doing. So what you can do is you can from google.colab import files, and then anything uploaded is equal to files.upload. So this is what we you have to type in Google Colab. So this is what you are supposed to type. So here the from is a keyword, and google.colab import files. So this is completely the line, standard line you are supposed to give, and you are supposed to upload. So you can even rename this as uploaded, and then you can do. So I can tell you how to do this one in Google Colab also. So just go to Google and then search Google Colab. So you will be this research.google.com will come. So just open this, open in a new tab. So Google Colab is opening, and go create a new notebook. Are you able to do this? Create a new notebook. Just click on to create here. Okay. So just click on to new notebook. So new notebook will be created for you, and you can't save this. That's the problem. So every time, if you want, you can save it somewhere in a Word, or you can save it in as a Python program, so that it is easy for you to copy and paste it here. So you can paste it here. So this is what you are supposed to do from google.colab import files, and this is what you are supposed to do. And to run this, you have a play button here. You can click on to run. My system is a little slow. Are you able to do this? You can type these things from google.colab import files.
Ma'am, it is asking choose files. Am I right?
Yes. So you can choose from your drive. So where you have stored, you can choose from the drive. Since it has been copied from yeah. So this is what it will ask you. So since it is being copied, suppose if you are copying it from PPT, some special characters, invisible special characters will be inserted in between. That is why the error, but the command is same. So the command which we have given is the same. It is from google.colab import this thing and choose file. You can choose the file. So this is just like browsing. So this is what I want to choose. And this file has been now saved in the Google Colab. So this is saved as iris.csv is saved as iris.csv itself. Now, if we want to read again, you have to do the read again. Now it is the same thing. Create another, either you can continue with this, or you can create every time you can create a code segment, and it is easy for you to find out what is the output of every code segment. So every time you can just click on to this add code, and then you can find out. Now you can read, you can use these commands you can use. So I'll just copy this. I am saving it here. And here, no point in specifying the local drive in the cloud. So it cannot identify the local drive. That is why we have uploaded this file iris.csv in the Google Colab. Now you can use the read. This is the command. The command is same. So df is equal to pd.read csv, and then give the file name, because the file name is already available in the Colab. Then we are executing the same set of commands what we did previously.
Ma'am, we didn't imported the libraries, no? That's what she did.
Yeah. Library has to be done, and the file name is also I caps.
Excuse me, madam, please write down your code in the chat box so we can use it.
Fine. I'll just copy this. First, I'll copy this. I'll run first. It is correct. Yeah. So this is what the result which we have seen. So either you can create your own, you can download Python ideally. That is also easy for you because here every time. Okay. Yeah. So this is how you can do. So the same operation what we have done by using Python.ideally, the same thing we have done it by using Google Colab also. And every time single statement also you can execute by just adding the code. If you want to add another code, then you can add another code also. So every time if you want to execute, you can execute anything and then you can find out the result. So this is one easy way as well as it is the fastest method also, as it includes. Okay, is that okay? Okay, so these are some of the operations which are performed on CSV file. So already we have seen read CSV and CSV, and one more thing is we have head and we have describe. And this is for non-numerical values. You can specify the column name and then value counts. So how many values? This will help you to identify the frequency. So you know, the mean, mode, median, and all those things, if you want to find out, that can be identified using this. And these are some other statistical function on data frames. The same thing how we have done in Google Colab or anything. Instead of head, instead of describe, you can use this one. You can use mean, or you can use, so here mean can be identified with axis is equal to 0. That means it is mean is for column. We are printing the mean for column, and this is the mean for rows. This can be, this axis is equal to 0, axis to 1 can be included in any of the functions. So count is again for which column name we are including. For that we are using the count, max, min, median, mode, and all those things can be calculated. These are the functions which are available for the DF. And what is DF? It is an instance of pandas. So PD dot only we are doing. So that is what we are doing. Next one is how to display the histogram. So many a times you have to identify how the data is being distributed, and histogram is one of the way in which you can identify how data is being distributed. So here what we are doing, we are reading again the pandas file and we are specifying this is PLT is for the plotting, and plot dot figure, and you can specify the figures. And those who are good at MATLAB, you might be knowing what is subplot. So we specify how many rows and how many columns can be specified. And what is your set X label will give you the X axis value, and Y label will give you the Y axis value, and the figure title can also be specified here. And this is what the actual function which we are using. Histogram, if we have to plot a histogram, hist is the function which is used for a Python instance. That is the data for the data frame. We have hist function, and for which column we are specifying. Always the column can be specified inside inside a single quote. And how many bins? So as you have seen the histogram, these are all called as bins, and depending, and these are all frequencies. So in the range of, this is for the users. I have shared you another user detail CSV. In the user detail CSV, we have the users as well as this is the age. So from 0 to 10, how many users are there? 10 to 20, how many users are there? So this is a bin, and every time the person who are lying within this particular value will be pushed inside that bin. So that is what this bin is. It will be pushed inside. So this is one way to create a histogram. And another way, very easy way, is to if you don't want any subplot and all, directly you can specify what is the X label, Y label, and the histogram can also be specified. And you can plot this. So here we are using plot dot hist. So this is another way in which you can you can project the histogram also. So I can show you that program also. So this is what the histogram is. So other than the histogram, we have something called as the scatter plot, and we have a box plot also. We have stacked, we have a bar chart that can also be done. And sometimes you can have a stacked bar chart also. So all these things are specified here. So this is one way. This is stacked histogram. So if you have to specify the stacked histogram, you have to specify stacked is equal to true. So one of the advantage of Python is you may have so many parameters over here. So for every function, you may have so many parameters, but which parameter we want to use, only that parameter can be used along with a parameter name. So what kind what kind of plot? So plot is a general thing. And what kind of plot we are using, whether you are going to use histogram or you are going to use scatter plot or you are going to use a bar chart. So that thing can be specified over here. So though you may have around 5-6 parameters here. So whatever parameter we want, only that parameter you can specify. That's the advantage of Python. And then stacked here is, if it is false, then it will not be a stacking. If it is true, then you can create a stacked thing also. So here we are plotting for the entire X. This is since Iris dataset is available online. This sklearn is very important for all data analysis as well as to do machine learning. sklearn will contain almost all the functionality, whatever classification, clustering, and reinforcement learning, whatever you need. All the functionalities, all the algorithms are implemented in sklearn. So you can download those libraries and then you can use it. And from sklearn, we are from sklearn, we are using the data set here. We are from sklearn.dataset. We are importing this Iris, load Iris. So the Iris dataset will be loaded and it is stored in Iris itself. We are storing it in Iris data frame here. And then from the Iris data frame, we are taking the data separately as well as the target separately. What is the data? The ID, sepal length, sepal width, petal length, petal width. Those things are data, and the last column, which is the species column, that is considered as your target. Now we so here this is where we are converting the data into a data frame and we are storing it, and then we are plotting all these things. So this is for your stacked histogram. So I can run this program for you. Yeah, so this is for the first code. So over here we have we are reading the figure and we have given the x-axis as age and y as user histogram, and bins is ranging from 0 to 80, and we are just through the function called show. And the next one is, this is the next one, along with the subplot. So subplot, we are so the previous thing is you will not be having the subplot. Here you will be having the subplot for every rows and columns also. So row count and column count can also be given in the subplot, and the rest of the things are all same. So the bins range you have to specify 0 to 10 and with a width of 10. So that is what we are specifying. The next 10 is with the width of next. And one more thing what we have is scatter plot. So for scatter plot, again you can use plot and the kind can be given as scatter. So previously here also you can give, even the histogram can also be printed with the same kind of format, specifying kind is equal to hist. Okay, so the next thing is, if you just close this, the next can be this one. This is the scatter plot. So scatter plot, this is again for the same user details. We are printing the age against income. So this is how it is being done. So as age goes high, the income is also high. This is what we can infer from this. So these visualization techniques are very much useful to infer some kind of information. So first of all, you should know how the data is being distributed. Then only you will be able to identify you can further proceed. So based on the data distribution only, you can choose the model even. So for some kind of model, even if the small regression itself is sufficient to predict your regression itself is sufficient to do some kind of analysis on your data set, why to go for a deep learning method? So it is unnecessary computational power. You are wasting the computational power if you are going, when a smaller and easier solution is available, if you are going for a critical, then that means the solution is inefficient because you are using much of the computational power. So that is why you have to analyze how the data is, how the data distribution is, and from these kind of distributions, you can find out how the you can infer some amount, some kind of information about the data. Then we have the next thing is we have box plot. So anybody knows about box plot? What is a box plot is? And what
5 data summation formula, ma'am, for statistical tools.
Can you repeat once again? I'm sorry.
It is 5 data summation form, like containing the range and the interquartile deviation, median.
Yes. Okay, median. And from that, what we can infer? What can we infer from the box plot?
The
mean
scattered
values.
Pardon? The mean?
Mean values.
Mean value, we can even get it. Normally this box plot will be used to identify the outliers also, but I can tell you what is box plot actually.
Scattered.
So this is, yes, so the skewness you can identify. So in what way it is skewed, and again this will very much helpful to you to analyze the data. So this is again for analysis of data. So this will, as one of the participant was correctly pointing out, it will give you all these values. One is it will give the minimum value and the quartile value. So 25% of the value will be summed up here, and it will give the median, which is the 50%. And you know what is the median, right? So we just when we are having all the numbers from minimum to maximum, so that is how this whisker is going. So we have maximum, and then here we have in the 25%, we are having one cutoff, which is the lower quartile Q1. And in the middle, we are doing another cut, which is the median. That is, median is the middle value, what we have when it is being arranged. And then the upper quartile is Q3, and then we have the maximum. Now, if you just see this one, this is the left skewed. So the skewness is towards the left side. Say, for example, if it is the student mark, we are doing a plotting and we are getting a left skewed curve for the student mark. So what does it mean? If we are getting a left skewed for the student mark, what does it mean? So that means majority of the students. So you have, say, for example, here you might have heard about mean, mode, and median. So these curves will exhibit those properties. We have mean, median, and mode. So median already you have, this is the middle value we have, and mean you have to calculate from the data set, and mode is the frequency. So which data comes for a longer time, that is the mode. So multi-mode, sometimes it may be multimodal also. So if it is multimodal, here you have, it is a single modal, you have only one peak. If it is multimodal, you may have too many peaks also. So that is what the multimodal. Now this is one mode we have. This is left skewed. What is the meaning? If it is left skewed, here also you can see it is left skewed. And the median, Q2 is the median here, and the median is shifted towards the upper part. So the skewness is in the left part. So the left end, we have the skewness. That means majority of the students have secured, say, for example, this point is something around 85. Most of the students have almost around 80 and above is very much high, and the rest of the very few students have got very less marks. That is the meaning. So all the students who are so we have seen the difference in this particular era. We have seen such kind of things a lot of such things, even if you are a student or if you are a faculty, whatever it may be, or a parent, whatever it may be, you might have seen the performance of the students. Before Corona, before online classes, the students' marks will be like this. It will be mostly right skewed. And now during Corona, after Corona, it is like left skewed. So all the students are securing more marks. It is almost 90%. That is how it is being skewed. So this is very much important for to analyze your data. So here your median, your mode will be greater, and then median, then you will be having your so what the case in when we are going for a left skewed data set. So this is how you can analyze the data. And if it is symmetric, what will be your mean, mode, and median? If it is symmetric data,
be equal, ma'am.
This will be equal. Yeah, all must be mean, mode, and median will be equal. This is your Gaussian. So the same way you have a right skewed also. So if it is a right skewed, then we have the skewness in the right side. So most of the students might be securing very less marks and so on. So the same thing is being projected here also in this diagram. So you can just rotate it this way, a right rotate, because this is the minimum and this is the maximum. So if you have seen these things, it is also it is a right skewness. The meaning is most of the salaries of the female is less, and the comparative salaries of the male is also less. Right, the highest peak is coming only in the left end, so it is right skewed. So this is how it is very much helpful to analyze about the data. So this I have given, and if I just close this, it is the stacking of the bar chart. Yeah. So this is the program, and should I copy this? And I think I have this has been shared in the Word. Should I copy and keep it in the chat box again? Yes, ma'am.
Yes, madam.
Yeah. So you can try this in Google Colab also. If you have Python, then you can use Python ideally, or you can use it in hope you are getting the answers. Yes, ma'am. The code is running. Okay, thank you. So this is how sometimes the outlier can also be identified. So as one of the participant was telling, this is called as interquartile range, and anything the minimum value compared to into 1.5 into this interquartile range, if it is less than that will be considered as outlier, and compared to this interquartile range into the maximum value 1.5 into interquartile range of the maximum. If it is greater than that, those things will be considered as outliers. So this box plot will be useful to identify the outliers also, and you can identify which points are becoming the outlier, and that points you can neglect, so that still you can improve your accuracy still more. And I can show you another histogram which contains the stacking perfectly. So you can get a lot of help from the internet. So you have that is the advantage of using Python. So this is histogram. So bar chart we have seen. So this you can try by yourself, and this is what called as a slicing operator in Python. So we have converted the data frame. The X data is converted into a data frame, and then we can you can fetch the column wise information. So mean, I just wanted to do a plotting for I wanted to plot the mean of every column. So how to fetch is, this is the column name, and what is the how many data points you have to collect. So data points means every row is called as a data point. So the data points, all the data points you have to collect, right? So you can use a slicing operator. You can specify this as 0 to 150, or if you are not specifying anything, all. So that means from the beginning till the end, all rows will be taken for the 0th column, and from the beginning till the end, all rows will be taken for column 1, 2, and 3, and the mean is being calculated, and we are finding out the bar chart. And here this is what the x-axis, and this will give you the height. So height in the sense that will actually plot the value. So either it can be a scalar value or it can be a vector value also. And what is the width and what is the color, and tick labels, if we are specifying, this will be specified like this. So this is what the bar chart is. And you can even do a stacking bar chart also, as we have seen in the previous example. So these are some of the additional commands which are there in data science, which will be much helpful for you when you are doing some kind of questions. As we have seen in the initial slide, we have a NumPy library. With that, we are creating a NP instance for NumPy is called as NP now, and you can create the array. And this Ravel, this will return a continuous flattened array. So these values, the list will be converted into array here. Over here, if you have to create a flattened array, suppose this is a list, and this will be created as a matrix. So in the first row, we'll be having 1, 2, 3, and in the second row, we'll be having 4, 5, 6. And then when we are calling np.ravel of x, if we want to make this as a flattened array, so some d-dimensional array, we want to make it as a single dimensional array. That is what we are doing it here. So that will become 1, 2, 3, 4, 5, 6, and so on. And sometimes we want to reshape the array also. And the reshape of array is arrange 6. So 6 will be creating 0 to 5 values will be done, and that has to be reshaped as 2 cross 3. So what is 2 cross 3? 2 rows and 3 columns. So 0, 1, 2 will be in the first row, and 3, 4, 5 will be done like this. So this kind of reshaping. So these are some of the additional commands which you can try later. And suppose if you want to fetch some information, specific information from the data set which we have. So those kind of things will always be recurring for us. So the DF, and then we can use LOC. So this is a LOC is a label based on the index based label based or index based indexing. So that is what we are doing here. And then 1 till the end we are collecting, and we are specifying. So first column, first field here is, it represents the row. So how many rows? All rows if we need, we are collecting it. 1, this is the slicing operator. So 1 semicolon and till the end comma. Then we have to specify which columns you want. Suppose if you want all columns, then you can specify colon also. So this is how you can fetch something, and it can be converted into a data through the array, np.array. So we are fetching some data frame values, and that can be converted into array for further processing also. So these are some of the additional commands which you may be requiring when you are doing your projects also. And as I told you, this is very, very important for doing all analysis of Python, which is sklearn. So using sklearn, one of the important function is fit. So whatever model we are using, every time you can use some kind of model, which is classification model, or you can use some kind of clustering. Whatever model you are using, that model has to be fit for the data set. So first of all, we are collecting the data set, and then you have to fit any model for that particular data. That will be done through the function which is called as fit, and that is called as sklearn. So that can be done through sklearn. Sklearn is again a library, and from that library you can you can use fit to do that. So next one is we have the data pre-processing. So how to handle the missing values. So as I told you, one of the pre-processing is to handle the missing values. This is very basic thing. So again, what we are doing is we can use imputer. So imputer is one of the function which is available so that you can replace the imputed values with some kind of strategy. So this is what the of imputer. Again, it is there in the library sklearn, and in sklearn pre-processing, then we have you can call imputer. And the missing values, what kind of missing values we are doing? If it is not a number, sometimes the missing values will be nil or null or even empty spaces and so on. So in general, you can make that as if it is not a number. NaN is not a number. So that is what we are specifying here. This is the condition you are supposed to specify. So you can specify the condition as. So this is what NaN is the not a number, and the strategy you can specify if it is not a number, if it is a blank space, or if it is nil or null, whatever it may be. How to replace? It should be replaced with the mean. So mean of what? Either mean of the column wise mean you can, or you can replace it row wise. So again, that depends on the axis. So axis is equal to 0 corresponds to column wise, axis is equal to 1 corresponds to row wise. Say for example, if we have a student database where the students marks 5 different subjects marks are there, maths, physics, chemistry, biology, say for example. And then if we have anyone for example, the student is absent for any one of the examination, it cannot be replaced by the column wise, right? So it will not give you column wise mean. We need to find out the average, how the students are performing on an average for mathematics, and you can compare it with on an average with biology. Whereas if the student mark has to be replaced when he is absent, you can replace it with the row wise replacement, because that will, most of the cases the student may get 70 or so, or if the students are getting 90, almost be getting more likely to be. So you can use, depending upon the application, you can use this axis as either 0 or 1. And again, the strategy over here, you can use anything. One is the strategy. You have 3 different options here. One is you can replace it with a mean, or you can replace it with a median, or you can replace it with the most frequently occurring thing. So whichever is comfortable to you, that you can use over here. Instead of mean, you can use median or most frequent. And this axis is again optional. Default is 0. If you want to make it 1, then you can make it 1 also. So this is again the example what we have used. NumPy we are using, and sklearn.import simple imputer. So this simple imputer is one of the technique to replace the values. So that we are, so again, if you want to find out the code for simple imputer, again you can go to Google and then check, search for the code of simple imputer. You can get the code also. But since all these things are available as a library, you need not to code it from the scratch. Directly you can call those functionality. You can do your manipulations, but you should know what is the functionality of all these things. And again, we are collecting the data as well as the target data in X and target in Y, and we are calling the simple imputer. That is what we have called over here. And missing value is NaN. We are using NaN, np.nan, and strategy which we are using is fit. And then, as I told you in the previous slide, fit is one of the important function which is used to fit the model for the data. So where is the data? The data is here. This is the data. X is equal to iris.data. We have the data in X. So this is not the scalar quantity. We have the vector quantity here. And then this fit is, we are calling fit for what? For this instance, for this object. Already you have created simple imputed, and object is created for simple imputed for that object. So this object represents what? This object will be representing simple imputed with these parameters, with NaN and with mean. So this is what the model. So we have the model now is being represented with the object name IMP. So IMP dot fit of this model has to be fit to what? Fit for the data. So just fit it for the data, and then you can print it. You can use transform of X. So transform of X is just to transform the values into any ways. Why we use transform of X. Even you can use lambda functions to transform the data. Any kind of manipulations can be done, and then the data can be transformed and so on. So here, whatever functions we have done, that should be transformed, and that is stored in K, and you can finally use show K. And now I can execute this also, the simple program, which is Singvalos. So now it is squeezed to text 150. As we have seen here in the data set, there is no missing value or no null value, nothing. So all these things are, we have values, and that is what I told you. This is a clean data set. So if it is a clean data set, then you need not to worry. You need not to worry about the processing. But still, we have applied this, so we'll be getting the same complete squeezed data. So if you just click on to this, the complete data, this is what it is being transformed. So the data is being transformed as an array, and then you can do any kind of manipulations on this. This is what we are doing. So this is the code. So the same code what we are doing, and then we are transforming and printing J. So this is the code, and again, if you want, I can copy this and push it into. Okay. So this is the output, and finally we can see the classification also. So this is the last topic which we are seeing. So this classification, as you all know, we have classification is applicable only for supervised data sets. So if it is supervised, you will be having the data as well as the target variables also. Now we have to train the data, and then some portion you can use it for training, and some portion you can use it for testing also. So this is again reading the file, and this is a function which we are using, and this function is called, this is what the first line which is being executed over here. So iris of target species is equal to species dot map. So we have some function which is called as map. So map will do, what map will do is, whatever values which we are generating using this function, that will get mapped with the species. And the map is again called with the object species itself. So what is species? We have the last column, and the last column in the data set name is species. So iris.species.map, and then you are calling this function. When you are calling this function, it will come to this. So this is get target iris. So we are coming to the function, and this is how the function can be defined in Python. So def get target iris, and this is the default value it takes as we are calling it with a species. So this will take species as a default value, and now we are checking whether species is equal to, we have 4 different categories. So we are calculating 3 here. If it is, we have only 3 categories. One is iris, setosa, versicolor, and virginica. If it is setosa, then we are mapping it to 0. If it is versicolor, we are mapping it to 1. And if it is virginica, we are mapping it to 2. So that values are being returned, and over here, all setosa will be mapped with 0, all versicolor will get mapped with 1, and all virginica will map to 2. So this is what we are doing, and that value is being stored in the target species. So this is what the target now. Now the target will be no more iris, versicolor, or virginica. Instead, it will all be in terms of 0, 1, and 2. So 0 represents setosa, 1 represents versicolor, and 2 represents virginica. And now we have to do the testing, the training part actually. So we are collecting data from 1 till all rows we are collecting, and then all columns also we are collecting. The sepal length, we can ignore ID. So normally when you have the data set and you have the features, simply you can't remove any one of the column or any one of the feature. You have to find out the dependency. If it is dependent on another, then you can't remove that. So only if it is independent. If it is independent, what is the meaning? The features are orthogonal to each other. If it is orthogonal to each other, then you can remove. Otherwise, you have to make it orthogonal, and then only you have to remove. Because whatever, say for example, when you call a point, how do you call? We have 2 axes, and then you have to project the value of one axis and just project the value of another axis, and it will get intersect at one point, and this is what we call it as point. So this is what we are calling it as versicolor or setosa or whatever it is. We are talking only with in terms of 2 dimension. The same thing is applicable for n dimension also. So if it is n dimension, again the same thing will happen. Suppose if one axis is depending on the other axis, say for example, if you are removing one axis, what will happen? The other axis will fall on the other any other axis. So when you are projecting, you will not get a point at all. You will just get some kind of straight line, and manipulating with that kind of data is meaningless. So that is why when you are removing it, you have to check for dependency. Across the features, you have to check for the dependency, and then only you can remove that. Now you have this ID is no way connected with the sepal length, width, and petal length and width, but you have to mathematically prove that the ID is not relevant at all. So, but here just for the numbering sake, we have included, so that is being removed from that. But these things are all interdependent. Sepal length, width, and petal length and width are all interdependent. So you can't remove one any one feature, otherwise it will become meaningless. So what we are doing, we are just collecting all rows for all the columns we are collecting, and that we are creating it as array. And so these are the manipulations which we are doing. So the actual point comes over here from sklearn dot neighbors import k neighbors classifier. So what we are implementing here is knn. So what is the functionality of knn? Knn, you have to specify how many neighbors. So already, say for example, you have some kind of labels over here. So all these are some of the labels. All are circles, and some are triangles, say for example. These things are already exist, and if any other the new thing is coming, so this is classified as class 1, and this can be classified as class 2. And now you have to, when a new object is coming, this new object you have to check whether this is belonging to class 1 or it is belonging to class 2. So how to identify? You have to identify based on the nearest point. So you can check with what is the distance between this point and the nearest points, and again you can check with the nearest points. So that is what we call it as k nearest. So how many nearest points you are choosing, that is what called as k. So the k neighbors you have to choose, and that can be given over here. In general, it will be given as 5. So in the if here we have checked with 4. Suppose if it is 5, it can be checked with the next nearest value also. So accordingly, whichever is closer, and the point will be classified under that particular class. So this is what the actual functionality of k nearest classifier or k nearest algorithm. Now we are calling that already. We have imported it. From where we have imported? We have imported from this library sklearn.neighbors, import k neighbors classifier, and then import sklearn, import metrics also we have done. Now this k neighbors classifier we have imported, that can be done. This is where we are instantiating the model. Model is being instantiated and we are creating an instance, and that instance is now called as KNN. And what is the neighbor size? The neighbor size is, in general, it is taken as 5. Now you have to fit the model. We have created the model, and now the model has to be fit for the data. So already data we have collected. X is the data where we have all iris data, which contains only these things. These things are the X data, and you have the Y. Y is the target. Okay, so what is Y target? That is what this target species we have. So over here we have we just fit the model, and then when it is fit, it will be executed, and then you can predict a new value is being given. So this value is 3, 5, 4, and 2. So using this, we can the computer can predict or classify that this point is belonging to iris setosa or class 0, 1, or 2. So this is what the classification is, and you can even perform some kind of perform some confusion matrix can also be done. So you just run this, and I think with this we can wind up. Is that okay?
Ma'am, one more question. Yeah, how to work with image data set in Python?
Yeah, similar to this you have to do, but you know, the simple classifications will not be done because the features will be much different for images. So the way in which you have to read is not as a CSV file. You have to read it as an image file. You have to read, and then you have to extract the features. So I have just given all these examples only for the numerical data, so that the data can be done in terms of CSV files. And if we can fetch the image features, and if it can be converted into these kind of parameters, then you can use the same thing. Or you have to go for the image file reading, and the manipulation is a little different. And another thing is the image data file sometimes the size of the image is much higher, say for example 1024 cross 1024 and so on. The processing and this kind of you have 5,000 data set of such kind of thing, then it become much tedious. That time you can go for a deep learning technique also. So the technique which you are using is, so this is the base and funda where you can use these kind of things, and how the model, first of all you have to instantiate the model, and then you have to fit the model and so on. The same way, if it is image data, it is not just read CSV, you have to read it as image file, and then the technique will be different. But you can call again, the standard libraries can be called.
One more question. MATLAB or Python, which is better for thermal image processing?
I am not sure about MATLAB, but Python you can get a lot of help. So that is why even if you have any error, if you are encountering with any error, you can just copy and paste it. You will get help. What kind of error it is, and how to rectify that error. So that as far as the help is being concerned, and lots of materials are available. And one more thing is, even any new updates, all those updates will also be available, and that depends on the user point of view. So how well you can use that can be done. someone will be, even you have R programming also. So many of the research scholars, even our institution, they use R programming, and many students, they prefer Python. So it is according to your comfortness, which comfort level you are in, because this data science is the current trend, and it is being implemented in almost all the things, even in MATLAB as well as in R or in Python. That's not a problem. And shall I just execute the last one? And
yes.
The KNN along with confusion matrix also we have given. So this is what we normally divide. If we want to divide it into test and train, then you have something called as train and test split. So how do we split it into train and set with a random state of 0? So randomly it will collect the information into by standard 80-20. So it will be doing into train and test, and then you can perform. Again, we are calling the k nearest k neighbor classifier with the neighbors size of 5, and then you can fit the model. For what you can fit the model for X train as well as Y train. That is how we have splitted it already. And then when you are creating the confusion matrix, this is what the function you have. You have confusion matrix, and then you have Y test. You can predict this. So this is what the prediction. So where we are, what we are predicting, you are predicting the X test. So we are training using X train, and we are predicting X test, and the corresponding values are available in Y test. So we are checking against these KNN predictions and the original values. For these original values, you can create the confusion matrix also. So this is how the functionalities are available in Python. The same way it is all available in R also, but Python has exclusive collections. So this is what the confusion matrix is. So in the first case, we have the first class is correctly classified as 13 is classified as this one, and there is no false false negatives. And here we have 15 is classified correctly, and 1 is wrongly classified as the third class, and here all 9 are correctly classified. So this is what our model is. So this model is being executed, and this is being done. Just copy this also into yeah. So this is how we have. I have few more slides, but you can explore. So with this knowledge, you can explore. All these things are available online. And thank you.
Thank you, ma'am. Now I request Dr. Rajeshri ma'am to felicitate our keynote speaker, Dr. Annie Utra.
Yes.
Hello, good evening, Annie ma'am.
Good evening,
It was indeed a very, very informative and in the real sense, hands-on session, ma'am. I was also parallelly running the code, and it was amazing. So you took us from the beginning, like, so those who don't know Python also can run it. Those who don't know statistics also can learn it. So very interactive way of teaching. I'm sure your students must be liking your teaching very much. So thank you for being with us, and on behalf of all the organizing teams of this R10 funded capacity building workshop, I would request you to kindly accept a token of appreciation, ma'am.
Thank you. Thank you so much. Thanks for the compliment, and thanks for patiently listening, and thanks to Devaraj sir and Preeta for inviting me and giving me this opportunity. Thank you all.
Thank you so much.
Thank you, ma'am. Now, participants, we have a case study competition. So I'll be sharing the screen and I'll tell you about the case study. You have sufficient time. You're not going to do during the session itself. I'll explain you what is a report that you have to prepare and you have to submit it before 7 o'clock today. So that is a Google form which I'll be sharing with you in the group. And in the Google form, you have to upload your document. And then our scrutinizing team will be checking your report, and winners will be announced for tomorrow. Okay. So I'll be sharing my screen for explaining the case study. So yes, so the case study is about, I can tell you the instructions. The participants are asked to select any one of the following case study, and you can use any software platform. So the report which I'm going to show you consists of 3 case studies. You can select any one case study as per your importance, and then you can work in any platform. You can work in Python or in MATLAB, anything. You can work it out. Submit your case study report along with the results within 7 p.m. by today in Google form itself. So in the Google form itself, there is a file upload option is there. So corresponding to the question you have selected, you have to upload your report. And the timing in the competition is from 4:30 to 6. It is written, but it will be accepted till 7 o'clock. Select any one case study among 3 and perform the case study. So what is the format for the case study report is, you can take down this things. This has to be there in your case study report as a heading. First thing is brief your case study. Select, then mention the platform name. Select the platform name. Then you have to mention the coding. You have to mention the coding, what you have written, and then you explain your results. So just take these 4 points, and this has to be there in your case study report. Brief your case study, mention the platform name, and put your codings, what you have done in that case study report, and explain your results. So first case study, let me explain you. You have to forecast the generation of solar PV system in real time in commercial building using any time series forecasting model. So this is the link. So this will be there in the Google form which I am sharing you. So there is a link. You can download that particular data set into your laptop and perform any time series forecasting model and forecast the generation. It's a solar data set for solar PV generation. Okay, this is the first case study. Any queries you can ask me after I explain all the 3 case studies. The second case study is about, there is another data set will be provided for the second case study. It is about, it consists of images of different types of soil, and we have written only 2 soil data sets there. One soil data set will be of clay and other one is of sand. Perform the classification on this image data set. And there are 25 images in the data set. You select 23 for training and 2 for testing. 25 images are there. Take 23 for training and 2 for testing. So you are doing classification problem here, and you have to classify which one is clay image and which one is sand image. Only 2 class labels. The third case study is on the things which you have which had a session today. That is, the data set consists of a healthy leaf and an infected leaf. You have to perform again the classification model on this image data set. In this also there will be 25 images will be there. You select 12 data set for training and remaining for testing. So I'll be posting the Google form now. Yes, this is the Google form in which if you any one of the participant open this Google form and check, you are able to see the questions and the data set. Yeah, someone have asked about the data set link. It is there in the Google form itself. You can open the Google form first, which I have posted to everyone. And below each question itself, the data set link is also available. So there is a file upload option also there under every question. So you have to write the name of the participant, name of the institute, and then 3 questions will be there. So which question you are selecting, corresponding to that, you add the file and submit it. So this is taken as a competition, and whoever is submitting your case study report, you will be appreciated, and special certificates will be provided for the participants who are participating for this competition also. And prize also will be given for the winners. Any doubts or queries you have regarding this competition, you can ask me.
Preeta madam?
Yes, sir.
If there are no questions, you can share the feedback form and you can close the session.
Yes.
We can close this Zoom meeting, no? We need not be on the line, correct?
Yes, we need not be on the line. Participants, you submit the feedback form, and then you can go for the case study competition also. And someone has asked whether all case studies are compulsory. No, you have to select only one case study out of 3. So that is an option. You can select any one out of 3 and submit the report in the Google form itself. And feedback form also all are asked to submit. So now we can leave the Zoom meeting, and tomorrow we can go for the 3rd day of the session. And this case study report, I hope you all will participate and get benefited out of it. Can we close the session, sir?
Madam, be on the line for 2 or 3 more minutes.
Okay.
There might be some questions from the participants. Wait for 3 more minutes and then we can close. Participants, you can leave and you can start doing the case study.
Participants, you can also try with online codings, which is available in website. The only thing is you have to try with this data set, see that it is running, and then you can submit your report.
Raghavendra, you can stop the live streaming and recording.
Sir, one more thing.
Okay, sir.
People are submitting the Google form without any uploads. Actually, the Google form which I posted is not for feedback. Okay.